Are you ready to learn how to build fully featured production-ready REST API with Node.js and Express? In this course, we'll take you from the absolute basics to advanced patterns used in real-world applications. We'll start by scaffolding the project and configuring environment variables, then walk step by step through building modular routes, adding robust error handling, integrating a database using Prisma ORM, and implementing JWT Authentication using Auth0 as an identity provider. Along the way, we'll enhance the API with features like logging using Winston, input validation with Joy, and efficient pagination strategies. We'll also explore architecture patterns like ports and adapters and DTOs and entities for clear domain modeling, and finish off with automated testing and Dockerizing for development. Each step of the way is captured in its own GitHub branch, so you can follow along and see exactly how the project evolves. By the end of this course, you'll have the tools and knowledge to confidently build scalable APIs using modern best practices in Node.js development. Hi. My name is Alex. I'm a senior software engineer with years of experience in JavaScript and Node.js. My goal is to help you become a confident and stress-free developer by increasing your skills and proficiency. Let's get started. Are you ready to kickstart your Node and Express journey? In this video, we'll walk through the essential steps to quickly scaffold a fully functional Express app from scratch. In addition to setting up Express, we'll integrate TypeScript and Jest for type safety and testing, configure ESLint and Prettier to ensure code quality, and finally, add Nodemon to automatically restart the Express app whenever changes are made to the code. I am in an empty folder, so let's initialize our Node.js and Express app by typing npm init-y. The code for this video will be available in the Git repository, so check out the description. Now let's install TypeScript packages: TypeScript, tsnode, types for node, and tsconfig node 20 base. tsnode package will let us run the TypeScript directly in the node without precompiling. tsconfig node 20 base is a base configuration file we will be extending since currently node 20 is the latest LTS or long-term support version. Next, we'll run npx ts-init, which generates a tsconfig.json file. Let's open it, delete the default content, and paste in our own configuration, which extends node 20 base tsconfig. This setup includes compiler options, outputs to a dist directory, and specifies that we'll include files from the src directory while excluding node modules and dist. To explore other tsconfig bases, head over to GitHub tsconfig repository where you can find more configurations. If you are using Node 22, you can install and use Node 22 base in your configuration instead of Node 20 base. Now, let's install Jest, ts-jest, and types for Jest, all saved as development dependencies. We'll then create jest.config.mjs file with the settings to use the ts-jest preset. Specify the test environment as node and set up testing for files with the src test directory. We'll also configure Jest to recognize .ts files. Next, we'll create utils.ts file in the src folder with some utility code, followed by a test for it in the tests folder. In the package.json file, we'll add scripts to run the tests in standard and watch modes, and then we'll run npm run test to verify everything is working. With testing set up, let's configure ESLint and Prettier. First, ensure you have the ESLint and Prettier extensions installed in VS Code. You can also enable format on save in the editor settings for automatic code formatting. In the terminal, run npm init at ESLint config to configure ESLint. We will want to check syntax and find problems. The module type will be common JS. There will be none for frameworks. Does your project use TypeScript? Yes. Where does your code run in Node.js? And install dependencies? Yes. After installing our dependencies, ESLint's configuration, eslint.config.mjs file is automatically generated, but we're going to update it shortly. Now we're going to install the dependencies to integrate Prettier with ESLint. You don't have to integrate Prettier with ESLint, but I prefer doing so. Let's install the following dependencies: ESLint plugin Prettier, ESLint config Prettier, and Prettier itself, using --savedev. Before we proceed, note that ESLint uses a flat config file and not all plugins fully support it yet. First, let's open the package.json file, scroll to the bottom, and add the following configuration. We will override the ESLint version, ensuring it matches the version of ESLint we're using. In our case, it's 9.12.0. If your ESLint version is different, adjust the override accordingly. After saving the package.json file, we can go ahead and install the pre-tier plugins. Next, let's update eslint.config.mjs file. Delete the existing configuration and replace it with the following code. Now let's break it down. ESLint configuration may look a little bit different to what you are used to because it uses the new flat config format. It exports an array where you can define configuration as objects. Each configuration object applies specific settings depending on the type of files and the rules needed. ESLint combines all the configuration objects, allowing those placed later in the array to potentially override the settings of the earlier ones. Let's walk through the configuration objects. The first object ignores the dist directory. The second applies rules to the src folder, focusing on JS and TS files. The next object applies common JS specific rules. Another object configures globals for Node.js like require and module. Then we use plugin like ESLint recommended for JavaScript and TypeScript ESLint recommended for TypeScript. We also configure jest-specific rules for test files in the src tests folder, adding the jest recommended rules and disabling jest prefer expect assertions rule. Next, we add custom rules. Here we disable at TypeScript ESLint no unused vars to prevent linting errors related to unused variables in TypeScript. We also configure pre-tier to handle automatic fixes for end-of-the-line differences with a end-of-the-line auto. You may adjust these rules depending on your needs and add your own custom rules. Finally, we include ESLint plugin pre-tier recommended, which applies pre-tier formatting rules and ensures ESLint integrates with pre-tier. It's important to place this at the bottom of the configuration to ensure it overrides any conflicting settings. Next, let's go back to the package.json file and add a script for linting. Save the changes and run npm run lint. Looks like we encountered an error indicating that the jest plugin is missing. To fix that, let's install ESLint plugin jest with npm install ESLint plugin jest --save dev. Once that's done, run npm run lint again. You might get a warning about TypeScript version compatibility, but it's nothing to worry about. ESLint will catch up with the newer TypeScript versions. If you are enjoying this video so far, please like and subscribe to our channel to help YouTube recommend it to more viewers. After configuring TypeScript, Jest, and ESLint, we can finally install Express. Let's install the following dependencies: Express, Course, and Morgan. This will be added as a production dependencies. We'll also install the types for these packages to work with the TypeScript as dev dependencies. Now let's create our Express server file in src server.ts. Here's the basic code. We import Express, Morgan, and Course. We apply middleware like Morgan for logging requests, Express.json, and Express.url encoded for parsing request bodies, and Course to allow cross-origin requests. We also create a simple health check route, get health, which returns OK true to confirm the app is running. Next, create an index.ts file in src folder to import and run the server. We'll listen on a port 3000. To streamline development, we'll use Nodemon to automatically restart the server on code changes. Install Nodemon as a dev dependency and create nodemon.json file. Configure it to watch the src folder and restart the server when changes are made to JS, TS, or JSON files. Use TS Node to run TypeScript files directly in Node.js without precompiling. Finally, add dev script in the package.json to run Nodemon. Now, when we run npm run dev, the server will start and restart automatically on changes. To test the API, create an API-test.http file in the root of the project. This file makes API requests similar to Postman. To make it work with a VS Code, install the REST client extension. After installing the extension, you will be able to send requests directly from this file. Run npm run dev to start the server. you'll see a message indicating the server is running on port 3000. Send a request to the health endpoint and you should get a response OK true. We can modify the code to test whether nodemon is working. Change the response to OK false and nodemon will restart the server automatically. Send the request again and you'll see the updated response. Now let's change it back to OK true. That's how you can scaffold a modern Node.js and Express app. There is more to cover, so be sure to check out the other videos in this series. In this video, we're diving into a critical part of any Node.js and Express app, configuring environment variables. Whether you are setting up secure API keys, database connections, or custom settings, mastering environment variables is essential to keep your app flexible, secure, and production ready. I am in Visual Studio Code working with a Node and Express app that I have scaffolded. This app is set up with a TypeScript and ESLint. As always, you'll find the link to the GitHub Repository with the code in the description below. Now let's create .env file and add node env equals development. It's also a good practice to create .env.example file to provide an example of environment variables for collaborators. This file ensures that anyone working on the project knows which environment variables are required. Next, open the .gitignore file and add the .env file to it so that it's not committed to your version control. In the server.ts file, we have a health endpoint. Let's update the response to include the node env value from our process.env object, indicating the environment the app is running in. After saving the changes, let's run npm run dev. Then open the API test.http file to make a request. Although we get a response, it seems the environment variable isn't being picked up. In production, environment variables are sourced from the actual environment, but in development, we rely on the .env file. The values from this file need to be loaded into the environment. There are different ways of doing it. I found the best way is to use .env CLI package. Let's install it as a dev dependency. Then update our dev script in a package.json to include .env-nodemon. Now run npm run dev. And if you send the request again, you'll see the environment variable is now included in the response. Rather than scattering process.env calls throughout your code, it's better to centralize environment variables in a configuration file. This approach allows for easier access, setting default values, and even modifying variables within that file. Let's go ahead and create a config file in the src folder and add the following code. We are defining two variables. The first is env, which takes its value from the node env environment variable. If it's not set, we'll default it to development. The second variable is port, and since environment variables are always strings, we'll parse the port as an integer. A configuration file is a good place to handle this logic. Finally, we export the config. Now let's open the server.ts file. We'll import the config and replace process.env.nodeenv with a config.env. One of the benefits of using a config file is the helpful hinting, so you'll know exactly what variables are available, which is particularly useful for larger projects. Next, go to the index.cs file, import the config there as well, and replace port 3000 with a config.port. We'll also pull the port dynamically using interpolation in the API is running message. Now, all we need to do is define the port in the .env file by setting port equals to 3000. And don't forget to update .env.example file with a port as well. Let's run npm run dev to make sure the app is still running on port 3000. Let's make a request using the API test.http file, and as expected, everything works perfectly. So the refactoring to a configuration file was successful. And this is how you configure environment variables in your Node and Express app. I hope this helps you better manage and centralize your environment variables. There is more to cover as we continue building the app, so make sure to check out the next video in the series. If you are building a larger Express.js app, you should not be handling all your routes in one file. In this video, I'll show you how to organize your routes efficiently using Express.js modular routing. We'll break down the routes into smaller manageable files to keep your codebase clean and scalable. I am in Node Express.js project. Let's add a few routes to our app. First, we're going to define the routes in API test.http file. We already have the health route in here. Let's paste a few more routes. These routes will be used to list tasks to get task by ID, to list projects to get project by ID, and to list tasks by project. You may also notice that we are using v1 in the path to denote the version of the API. When we come up with a second version of the API, we can namespace and develop the routes under v2 while keeping version 1 still intact. This will allow the API users to take their time to transition from version 1 to version 2. Let's go ahead and implement the routes we just defined. However, if we put all these routes in one file, server.ts in our case, that will be not very manageable. The better approach is to use a modular routing, basically creating a folder structure for the routes. So let's go ahead and create index.ts file in src routes v1 folders. We're going to place all our routes in the routes folder and in the v1 folder for version 1 API implementation. We're going to put the following code in index.ts file we just created. This code defines a modular API router for version 1, v1, of an Express.js application. It imports two subroutes, tasks and projects. These routers handle task-related and project-related routes, respectively. The v1 router uses these subroutes by mounting them at the /tasks and /projects paths. Finally, the v1 router is exported for the use elsewhere in the application, allowing easy organization of routes. Now let's go ahead and define our tasks routes. We will create index.ts file in src routes v1 tasks. Let's put the following code in this file. This code sets up a simple Express.js router for handling task-related HTTP requests. It imports Express and two controller functions, listTasks and getTask, which manage retrieving task data. A router instance named tasks is created and two routes are defined. Get / calls listTasks to retrieve a list of tasks. Get / ID calls getTask to retrieve a specific task by its ID. Finally, the tasks router is exported for use in other parts of the application. Now let's create a controller.ts file in src routes v1 tasks folders. Let's put the following code in here. For now, we're just going to go for a naive implementation. This code defines two functions, listTasks and getTasks, using the Express.js framework. These functions handle HTTP requests and send JSON responses. ListTasks, when called, it responds with a status code of 200 OK and an empty array in JSON format representing an empty list of tasks. GetTask, this function also responds with a 200 status code and returns a JSON object containing a single task with ID of 1 and name task1. Both functions use request and response types imported from Express, ensuring the request and response objects are typed correctly for TypeScript. Now let's create routes for the projects. But before we do that, if you are learning something new from this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. In the same way as with the tasks, we are first going to create index.ts file in src routes v1 projects folders and put the following code. This code sets up Express.js router for handling routes related to projects. It imports necessary modules from Express and functions from the controller and defines three routes within the project's router. Projects.get / this route triggers the list projects function, which returns a list of all projects. Projects.get / ID. This route calls the getProject function, which retrieves a specific project by its ID, passed as a URL parameter. And projects.get / ID / tasks. This route invokes the list project tasks function, which returns tasks associated with a particular project identified by its ID. Finally, the project's router is exported as the default export for use in other parts of the application. Next, let's go ahead and create project controller in src routes v1 projects folder. In the controller, we will define functions that will handle the responses related to projects. List projects responds with a 200 status code and an empty array in JSON format representing an empty list of projects. Get project returns a 200 status code and a JSON object containing a single project with ID 1 and name project 1. List project tasks responds with a 200 status code and an empty array representing an empty list of tasks for a project. The functions use the request and response types from Express, ensuring TypeScript types are enforced. The tasks and projects routes are defined. Now all we have to do is to use them in a server.ts file. Let's open server.ts file. We're going to import v1 router from a module located in the /routes/v1 file. And towards the bottom of the server function, we're going to mount v1 router on the /v1 path. This means that all the routes defined in the v1 router will be accessible under the /v1 URL path. Let's go ahead and save the changes. Now we can start our server with npm run dev and test the routes. Let's go to API test.http file and let's send get task request. And as you can see, we got a response OK200 with an empty array. Let's check the task by ID and we got a response with ID of 1 and the task name task1. Let's test the project routes in the same way. We get an empty array for get projects route. Get project by ID route gets project with ID of 1. And finally, the get projects task endpoint will give us an empty array with a response 200 OK. That's a wrap on Express.js modular routing. Now you know how to keep your routes clean, organized, and scalable. I hope you found this helpful and will be able to use modular routing in your Express projects. In this video, I will explain how you can handle errors in your Node and Express.js project, ensuring your app stays stable and user-friendly. We'll cover how to create a custom error handler as well as how to throw custom errors. I am in the Node and Express.js project. Let's take a look how error handling works in Express. Let's go ahead and open src folder. Go to v1 routes tasks folder, and in the controller.ts file we defined two functions, list tasks and get task. Let's go ahead and throw an error in the get tasks function. We will start the server and open API test.http file to make a request to get task by ID endpoint. We can see that we got an error response. It's not a pretty response, but it will do. It says error oops, we got an error stack, and we can also see that error is logged to the console. So API didn't break, although we didn't handle the error we threw. If we are going to try again, we're going to get the same response. So API is working just fine. Express has a default error handler that tries to catch all the errors and then returns the response and logs out the error stack. Now let's go back to the controller and change the function getTask to be an async function. Let's hit the endpoint getTask by ID again, and now we can see we didn't get any response. Express failed to handle this error and crashed. Express version 4 does not handle errors in the async route handler functions. From my experience, I can tell that route handler functions will be mostly likely async because you will be either making a request to the database or some other APIs to get data and return it to the user. To handle the error in Express 4 in the async route handler function, you need to use try-catch. Let's go ahead and use try-catch. We're going to try, catch the error, and pass it to the Express error handler using next function. Move the code inside the try block, and we need to add next function as a parameter and import its type from Express. Now let's go ahead and repeat the call again to get task by ID. The app doesn't break. It returns the error response as before and logs the error stack to the console. As you can imagine, it's easy to forget to use try-catch in route handler functions everywhere in your project. Fortunately, Express 5 is out, and it added support for returned rejected promises from errors raised in middleware. Basically, what it means is that we don't need to use try-catch in route handler functions anymore in Express 5. If you would like to learn more about Express 5 release and new Express features, please check out my video on this topic. Let's go ahead and upgrade to Express 5. In the package.json file, we can see that Express package we have installed is version 4. Currently, Express tag latest is still version 4. So in order to install version 5, we need to use next tag. Let's go ahead and do npm install express at next. Now, as you can see, we have Express 5. And also you need to check that the types for Express are also at version 5. I have them at 5. Unlike with Express, the latest tag for Express type is 5, not 4. If your Express types for some reason don't have version 4, all you have to do is to use the following npm install at types / express at latest. This will upgrade Express types to version 5. Now let's go ahead and remove try-catch block that we put in place before, save the changes and start the dev server with npm run dev. We'll go to API test.htp file and try the request again. As you can see, we're getting a response, so the server doesn't crash anymore even if we don't use try-catch. Default error handler in Express does a pretty good job at responding with error and logging it out, but in most cases you would want to use your own custom error handler first before Express's default error handler kicks in order to return a custom response to a user and not just the error stack. So let's go ahead and create a custom error handler. Let's create errorhandler.cs file in src middleware folders. We're going to put the following code in there. We're going to import next function request response from Express to type the function parameters for TypeScript config that contains configuration settings like a debug mode. We will add debug property to the config shortly. Get error message, a utility function that extracts an error message from an error. In Node.js, any type can be thrown and you can expect to use .message to access error message. We will also create get error message function in a minute. We export default error handler function that has the following parameters. Error of type unknown for the reasons we mentioned earlier. Rec res next represent the request, response, and next middleware functions respectively. You may notice that unlike route handler function, error handler function has error as the first parameter. Error handler function has the following logic. If the response headers have already been sent, res.headers sent, or the application is in debug mode, config.debug, the error is passed to the default error handler using next error. Default error handler does a good job of logging errors, so we can use it if we can't send a response since it is already been sent and or we want to log the error. Otherwise, it responds with a 500 status code and a JSON object containing an error message. The message is either retrieved using a get error message function or defaults to a generic default error message. Basically, the goal of the error handler function is to handle server-side errors and ensure proper logging and response to the client. Now let's go ahead and define get error message function. Let's open the utils file and put the following code in there. This code defines a function called getErrorMessage that takes an error parameter of type unknown and returns a string. It handles different types of errors and extracts the error message. If the error is an instance of the error class, it returns the message property. If the error is an object with a message property, it converts and returns that message as a string. If the error is a string, it returns that string directly. If none of the above conditions are met, it returns a default message an error occurred. This utility function is useful for safely extracting error messages from various types of errors that might be thrown in a JavaScript or TypeScript application. Next, we will update the config.ts file to include a new debug property. This property will be based on the app-debug environment variable. We will set it up so that if app-debug is set to true, our debug mode will be activated. If app-debug is either false or not set at all, debug mode will be off. The final step is to add the error handler in the server.ts file. But before we do that, if you're learning something new from this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. First, we need to import the error handler. Then we'll correct a typo by renaming middleware folder to middleware. After saving these changes, we'll add the error handler as the last middleware in our create server function. To do this, we'll use use error handler at the bottom of the server.ts file. This ensures that the error handler will be the last middleware to process requests. Once we made these changes, we'll start the server with npm run dev. We can then test our implementation by sending a request to get a task by ID using the API test.http file. As we can see, our custom error handler successfully captures the error, extracts the message, and sends it back to the user. However, during development, we might want more detailed error information. Let's configure this by setting up the app-debug env variable. We'll add app-debug equals true to both our .env and .env example files. After saving these changes and restarting the server, let's make a request to the getTaskById endpoint. We receive a response containing the error stack trace. This occurs because the app-debug logic is active. Checking the app-debug environment variable and passing the error to default handler, which then returns the detailed stack trace for debugging purposes. In addition to a custom error handler, it's beneficial to create custom errors for better flow control in our application. This approach can enhance our error handling strategy. For instance, in our test controller, we have an opportunity to implement a more specific error. Instead of a generic error, we could use a custom entity not found error. This would be particularly useful in scenarios where we are trying to retrieve a task that doesn't exist for a given ID. Let's go ahead and create custom error.ts file in the src errors folders, and we'll put the following code. This code defines a custom error class called custom error that extends the built-in JavaScript error class. Custom error will be a parent class for all other errors to extend from. Here's a breakdown of the structure and functionality. The class uses a generic type C that extends string. This allows for custom error codes to be passed when creating an instance of the error. It has three properties: message, a string describing the error, status code, a number representing the HTTP status code, for example 404 for not found or 422 for unprocessable request, code, an optional property of type C for a custom error code. The constructor takes an object with the three properties: message, required string, status code, required number, and code optional of type C. In the constructor, it calls super to properly initialize the base error class, and it assigns the passed values to the corresponding class properties. The custom error class allows for creating more specific and informative error objects in your application, which can be especially useful for API responses or internal error handling. Now let's go ahead and create entity not found error class. We will create it in src errors folders as well. Since we're using custom error as a parent class, the code for entity not found error class is quite simple. We import the custom error class from the file we just created. The entity not found error class extends custom error with a generic type parameter error code. We will define error code type in a minute. The class body is empty, which means it inherits all properties and methods from custom error without adding any new ones. So let's go ahead and define the error code type. We are going to create type definitions file types.d.ts in the same src errors folder. We will add the following code. This code defines a TypeScript type called error code. It uses a union type to specify two possible string literal values. R and F stands for not found error. Error valid stands for validation error. This type definition allows you to use these specific error codes in your application, ensuring type safety when working with error handling. Next, let's update the error handler middleware to add our custom error. We'll modify the code to check if the error is an instance of our custom error class. To do this, we first need to import the custom error class into our middleware file. Next, we'll add logic to check if the error is an instance of our custom error class. If it is, we'll respond with a JSON response containing the error message and an appropriate status code, which could be 404 or 422 or something else. This approach allows us to handle our custom errors more precisely, providing more informative responses to the client. Now let's update the tasks controller. Instead of using a generic error, we'll throw the entity not found error. We'll start by importing this custom error class. When creating an instance of entity not found error, we'll provide an object with the following properties: message entity not found, or you can also put task not found, status code 404 indicating a not found error, and code R and F. Let's test our custom error implementation. After running npm run dev, we encounter a TypeScript error. This indicates that our types definition file in errors folder isn't being recognized by TS node. To resolve this issue, we need to make an adjustment to our tsconfig.json file. We add TS node files true to our tsconfig.json. After saving these changes and restarting the server, our setup should be functioning correctly. The API is now running on port 3000. Let's test it using the API test.http file. When we send a request to the getTaskById endpoint, we notice that we are still receiving the full error stack trace. This indicates that our debug mode is still active. Let's update our environment variable. In the .env file, we'll change up debug to false. After saving this change and restarting the server, let's try the request again. This time we receive our custom error message, entity not found, along with the error code R and F. This is how you can implement custom error handling and custom errors in your Express.js application. By following these practices, you can significantly improve your app's stability, provide more meaningful feedback to users, and make debugging easier. Want to supercharge your Express.js app with a modern, flexible database solution? In this video, we'll dive into integrating Prisma ORM to streamline data handling and simplify your Express.js database connection setup. I am in a Node.js Express app where we have set up routes for tasks and projects, but they currently return empty responses. Let's update these routes to return actual data. We'll start by installing Prisma and adding it as a dev dependency. Then we'll initialize Prisma with npx prisma init, choosing MySQL as the data source provider since we'll connect to a MySQL database. The initialization provides us with a list of next steps to continue the setup. To get started, we'll set the database URL in the .env file. We'll skip the Prisma DB pool step since we don't have a pre-existing schema. Next, we'll run Prisma generate to create the Prisma client, enabling us to query the database. If you would like to dive deeper into Prisma, you can check out their Getting Started documentation. Let's open that .env file. Prisma generated a sample database URL, which we'll replace with our actual database connection URL. I already have DB server running in Docker and created a database named Task Manager. If you would like to learn how to run MySQL database in Docker, please check out the video on how to set up SQLize in Node.js project. Next, let's go to the Prisma folder. Prisma generated a schema.prisma file for us with a basic configuration. This Prisma configuration defines a client and a data source. The generator client block specifies that Prisma should generate the JavaScript Prisma client.js for interacting with a database. The data source DB block sets up the database connection. Here, provider equals MySQL designates MySQL as the database provider, and URL equals env database URL retrieves the database connection string from an environment variable that we set up earlier. You can also notice that schema.prisma file doesn't look very good, and in order to make it look better, we need to install Prisma extension for VS Code. So let's go ahead and look for Prisma extension and install it. After Prisma extension is installed, we can go back to Prisma schema file, and we can see that the file is looking much better now. In the schema file, we will be defining our models. Our application needs to have two models, task and project. Let's start with the task model. This Prisma schema defines a task model with the fields corresponding to task properties: ID, primary key for each task, set as a generated string CUID. CUID is a sequential unique identifier, therefore it can be indexed faster than the UUID. You can also use auto-incrementing integer for the primary key. User ID, required string field stored as a 36-character varchar in the database. We're not going to store users in the database, at least for now. User information usually comes from identity providers such as Auth0 or AWS Cognito. User IDs, there normally are UUIDs, and user ID data type accounts for that. Project ID, optional string referencing an associated project. Name is a task name as a string. Description is optional text field. Its native MySQL data type is also text. Due date and completed on, optional date fields. Created at defaults to the current date and time. Updated at auto updates to the latest modification time. Task model has a foreign key relation to project model that we will create in a minute. We're adding an index to the user ID field to make retrieving tasks specific to a user faster and more efficient. Finally, we'll name the table tasks lowercase plural. This is the convention I like to use. Now let's go ahead and define project model. The code for the project model will be the following. ID is a unique identifier automatically generated using CUID. User ID, a variable character string linking the project to a specific user. Name and description are project details, with a description being optional. Created at and updated at, track timestamps, with updated at automatically updating on record changes. Tasks is a relation field connecting multiple tasks to the project. This field is not stored in a database, but will be present on Prisma model. Additionally, user ID has an index for faster lookups, and the table name is mapped to projects in lowercase plural form. Since the schema was updated, we need to run npx prisma generate to refresh Prisma with the latest schema. This command installs the Prisma client package in the project and generates the client in Node modules. We can then start importing the Prisma client and querying the data. Let's create the Prisma client in the src folder to get started. The code for Prisma client will be very simple. The code imports Prisma client class from @Prisma client package. A new instance of Prisma client is created and assigned to Prisma variable, establishing a connection to the database. Finally, it exports this instance as the default export, allowing other parts of the application to use Prisma for database operations. Now let's go to package.json file and define a couple of Prisma scripts. But before we do that, if you are learning something new from this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. We're going to add Prisma generate script that we ran earlier. We will also add a migration script. It will run Prisma migrate dev with a flag create only. You can actually run Prisma migrate dev without this flag to create migration and apply it to the database in one go, but I like to create migration first, review it, and only then apply it with a migrate script Prisma migrate deploy. Let's create our first migration with npm run migration create script. We will name the migration create tasks and projects tables. Prisma created the migration for us, and this migration is in Prisma migrations folder. This is an SQL file. Let's take a look at it. This file contains the MySQL code for creating the tasks and projects tables, including all the fields defined in our Prisma schema. The ID fields act as primary keys, and there is an index on user ID for both tables. Additionally, there is a foreign key constraint for project ID in the tasks table, which references ID in projects with onDelete set to null and onUpdate to cascade. It's good to review these migrations for adjustments, as Prisma might not allow column reordering. Once confirmed, we apply the migration with npm run migrate, and it looks like migration was applied successfully. Next, let's go ahead and update the code and the controllers. Let's go to the project controller. We're going to import Prisma from Prisma client. In the list projects function, we will get the projects using Prisma's find many method. In get project function, we will retrieve project from the database using Prisma's find unique method based on the project ID received from the request parameter. If the project does not exist, it throws entity not found error with a 404 status code, an error message project not found, and a custom error code. Finally, in list project tasks function, we put the code that fetches all tasks associated with a specific project from the database using Prisma's find many method. The where clause filters tasks based on the project ID field, which matches the ID provided in regparams.id. This allows for retrieving only tasks related to the specific project. Now let's go ahead and update the tasks code in the task controller. We will import Prisma from Prisma client the same way we did in the project controller. In list tasks function, we will retrieve the tasks using Prisma's find many function. In get task function, we will put the code that retrieves a specific task from the database using Prisma's find unique method, filtering by the task's ID from the URL parameter. If no task is found with that ID, it throws an entity not found error with an error message, task not found, a 404 status code, and a custom error code. Now let's run npm run dev to make sure our code is still working. We'll open API test.http file and make sure the routes return responses and don't break. It looks like the routes work fine, however, they don't return any data. Let's add some data to the tables we created in the database. I am in Table Plus, where I have Task Manager database open. There are 3 tables: tasks, projects, and Prisma migrations. Prisma migrations table is created by Prisma automatically to keep track of the migrations. So now let's go ahead and create a task. I'll add a new row with an ID using a random CUID. You can generate one with an online CUID generator, and a user ID, which can be a UUID. For now, I'll leave the project ID as null. The task name will be task1, and the description, due date, and completion date can remain null. I'll set the updated app to 2024 10/31 01 02 03. Normally, Prisma will auto-populate the updated date. However, since I'm entering the data manually, I have to do it. Then I'll create a project with a CUID assigned as a user ID, set project 1 as the name, leave description empty, and add the updated add date. The tables are now populated and ready for queries. Let's switch back to VS Code and make calls to the endpoints again. Call to get tasks is now returning an array with 1 task. Get tasks by ID will return a not found error since the ID is 1. However, if we put the correct ID, we will get a task that we created in the database. In the same way, we can test projects endpoints. Get project endpoint is going to return us a list with 1 project. Get project by ID will get us an error not found unless we put the correct project ID. Finally, get project tasks will return an empty array even if we use the correct project ID, because there are no tasks assigned to the project. That wraps up our guide on using Prisma ORM with Express.js. You've got the tools to set up a powerful Express.js database connection that's easy to manage and maintain. Need mock data or essential entries to kickstart your project? Discover how to quickly seed your database with Prisma. In this video, we'll show you how to set up and populate your database effortlessly, making development a breeze. I am in Node.js project application where I have Prisma set up. Now let's add some mock data to our database. First, let's add the Faker.js library as a dev dependency to create sample data. Faker is my go-to library with well-organized documentation available at faker.js.dev. You'll find an extensive API reference there. For example, the person module lets you generate details like bio, first name, full name, and more. It even includes options like specifying gender when generating first name. Faker makes it easy to create realistic data, definitely worth checking out. Let's get back to our project. Next, we'll create seed.ts file in the Prisma folder and add the necessary code. We'll import Faker and Prisma client, instantiate Prisma client, and add a helper function to capitalize the first letter of a word. We'll then create an array of user IDs with random UUIDs. In the main function, we'll loop through the user ID and create a project for each, with each project having a user ID and capitalized name generated by Faker. Next, I'll add a for loop that will run just twice, creating a task in each iteration. Each task will include a user ID, and if the iteration index I is even, a project ID. Otherwise, it will not have one, allowing the task to optionally link to a project. Each task will also have a name with the first word capitalized, a description generated by Faker, and a due date set to a random date in the future. Finally, I'll call the main function. If it succeeds, I'll disconnect from Prisma. If it fails, I'll log the error, disconnect from Prisma, and exit the process with a code of 1, which is standard practice in case of errors. The seed.ts file is a TypeScript file, but since it's located outside the src folder, it won't be included by our main tsconfig.json. The simplest way to enforce TypeScript settings for seed.ts is creating a new tsconfig within the Prisma folder. Let's go ahead and create tsconfig.json in the Prisma folder. In this tsconfig.json, we simply put the code that will extend tsconfig for node 20. Next, in the package.json file, we're going to add a script to run the seeder. But before we do that, if you're learning something new from this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. We'll put dbseed, Prisma dbseed. Now we need to tell Prisma which file to run and how to run it when we run the command prisma dbseed. So at the end of the package.json file, let's add the following code: prisma seed tsnode prisma /seed.ts. This code tells Prisma to run the seed.ts file using tsnode. Now all we have to do is to run dbseed command with npm run dbseed. It looks like the database has been seeded successfully. Let's switch to Table Plus and check it out. In Table Plus, after refreshing the projects table, we see that the seeder has successfully created 3 new projects. Similarly, in the tasks table, we can observe tasks that were generated by the seeder. Some are linked to the projects, while others are not. This confirms that the seeding process was completed successfully. That wraps up seeding database with Prisma. Now you are set to quickly fill your database with a sample or essential data to kickstart your project. With our API delivering data, it's time to secure access. Head to the next video in this series to learn all about API authentication and control data access for the right users. In this video, we dive into JSON Web Token, JWT Authentication in Node.js to ensure secure access to your API. We'll cover the essentials of setting up JWT and how to validate it on protected routes. I am in Node.js Express project where we set up routes for tasks and projects. Let's go ahead and protect them with JSON Web Token. We are going to start with installing JSON Web Token library. We will also install the types for this library as dev dependencies. In order to create and validate JSON Web Token, we will need a secret. Let's open that env file and add a secret. For security purposes, the secret should be at least 32 characters long. Let's also add this secret to the config.ts file. Now we're going to simulate authentication server that will issue us a JSON Web Token. Let's create a file issue_test_token.cs in src directory. If you are wondering how to create an actual authentication server in real life, well, the answer is don't. Don't try to do this because there are other options available that are secure and have a lot of features. Those options include Auth0, Cognito, Firebase, just to name a few. As a matter of fact, in the next video we'll look at how to integrate Auth0 service with our API. Please check it out. In issue_test_token.cs we're gonna put the following code. We are going to import JWT from JSON Web Token library and config from config.cs. We are going to define payload with a sub property to which we assign an empty string for now. Next, we'll generate a JSON Web Token with JWT sign. We will use the payload we just created and a secret key from the config. In options, we'll put expires in 1 hour and the issuer will be Task Manager app. Then we will console log the token. Now let's go to seed.ts file in Prisma folder. Let's copy one of the user IDs we used for seeding the database with the tasks and projects. Go back to issue_test_token.cs file and put the ID in the sub property. Now let's generate the token. We will use tsnode to run issue_test_token.ts file and .env to inject environment variables. In particular, we need app secret. The token has been generated and we can copy it. Let's go ahead and take a look what this JSON Web Token contains. We are going to head to the site jwt.io and paste the token. As you can see, the token has header with the algorithm and type. It also has a payload, and this payload has a sub property that we defined, which stands for subject. It also has IAT, issue date, and EXP, expiration properties that tell us the token is valid for 1 hour. The ISS, or issuer, is our task manager. JWT and its structure is out of scope for this video, but if you want to learn more, please check out the link in the description. Let's head back to VS Code and create a middleware that will authenticate our user. We're going to create authenticateuser.ts file in the middleware folder. In this file, we're going to put the following code. We're going to import request, response, and next function from Express, and also JWT and JWT payload type from JSON Web Token. Additionally, we're going to import authentication error and config. The authentication error doesn't exist yet, we will create it later. First, we're going to define authenticate user function, and this function is a middleware, so it will take request, response, and next. Then we will assign authorization header from the request to the auth header variable. If there is nothing in auth header or it doesn't start with a word bearer, we will throw an authentication error with the message authorization header missing or malformed, status code 401, and code auth. If the condition passes, we're going to assign the part that goes after the word bearer to the token variable. Then we will do a try-catch block. In the try part, we will attempt to decode and verify the token with JWT verify method, passing in the token and the app secret. If the verification is successful, we will assign an object with a payload and token properties to reg.auth. The auth property will need to be typed on the express request. We will take care of it in a little bit. If everything goes well, we will call next function, but if we catch an error, we are going to throw a new authentication error. This error is going to have a message, you are not authorized to perform this operation, status code 403, and auth code. Now let's go ahead and define authentication error class in src errors folder. The code in this class will be simple since we can extend from the custom error class. We will also update error code type by adding auth. Finally, we need to make the TypeScript happy and also add auth property to the express request. We will create express.d.ts type declaration file in src folder. In this file, we will extend a request interface of the Express framework. We're going to import Express and JWT payload from JSON Web Token, we use declare global syntax to add custom types globally within an Express application. Declare global declares a global augmentation allowing modifications to the existing types in the global scope. Namespace Express targets the Express namespace specifically, which contains types related to the Express framework. Interface request extends the request interface, adding a new optional auth property. The auth property contains payload of type JWT payload and token of type string for the raw JWT. By adding this auth property, this code allows us to access rec auth payload and rec auth token directly in Express request handlers with the TypeScript support. Next, we are going to apply the authenticate user middleware to the routes. So let's go into routes, tasks, index.ts file. We will import authenticate user from authenticate user middleware and use it as the middleware for the tasks routes. Let's go to routes, projects, index.ts file and do the same thing for projects routes. Finally, we need to ensure that the authenticated user can only get his or her tasks and projects. So let's go into the tasks controller. In the list tasks function, we will add options to Prisma task find many. The options object contains where property with a user ID assigned from rec auth payload sub. In the get task function, we'll add the same user ID property to the where property in the options of Prisma task find unique. Now let's go to the projects controller and do the same updates. We will add options with where property with a user ID to Prisma project find many and update where property with a user ID in the options of Prisma project find unique and Prisma task find many. We are all set. Let's go to API test.htp file and test our work. Let's hit the route tasks. We got an error that authorization header is missing or malformed. Well, we obviously don't have any authorization header on the request. Let's go ahead and add it and use the token we created earlier. Let's go ahead and make a call again. Now you can see that we got the tasks and those tasks are the only tasks that belong to the authenticated user. Let's go ahead and add authorization header to get task by ID route. And if we send the request, we can see that the task is not found because the task ID in the request parameter doesn't belong to the user. Let's update the ID with one of the tasks that belong to the user. Now we got the response back containing one task, so the code is working. That's a wrap on JWT token authentication in Node.js. Now you know how to secure API endpoints, validate user access, and protect sensitive data with a JWT. As I mentioned earlier, it is not a good idea to create your own authentication server from scratch. A much better approach will be to use an already available solution out there, such as Auth0. In this video, we're going to learn how to integrate Auth0 API authentication into your Node.js Express project, allowing effortlessly authorized users to access their data. Hi, my name is Alex. I am a senior software engineer with years of experience in API development. My goal is to help you become a more skilled and proficient developer. Let's get started. I am in a Node.js Express app. We secured the routes with a JSON Web Token that we manually generated. However, in real life, this token needs to be generated by a secure authentication server. One of the better solutions out there is Auth0. Let's learn how to authenticate users in our API using Auth0 access token. As usual, the link to the GitHub repo with the code is in the description. I am in Auth0 dashboard. Let's go to Applications and create a new application. We're going to call it Task Manager App. We will select a regular web app. This type of application will be using code authorization auth flow. We're not going to select any apps. We will just go to the settings. In the settings, we'll leave everything as is. Later on, we will update callback URLs section. A more in-depth Auth0 tutorial is out of scope of this video. If you'd like to learn more about Auth0, please check out the link in the description. Next, we're going to create an API. So let's go to APIs and click on Create API. we will name our API Task Manager API. API identifier is the audience of a token, its intended recipient. In our case, the recipient is a Task Manager API, so we can put Task Manager API. We will keep JSON Web Token profile as Auth0. We will also stick with RS-256 signing algorithm because it is the most secure. Let's click Create. We are presented with a quick start guide. This guide has a code example for Node.js. This code suggests to use Express Auth0 JWT Bear library. We're going to be using this library in our code. Let's select Settings. General settings include ID, name, identifier. Access token settings contain settings you can tweak depending on the use case. We're going to leave everything as is. Now we need to get an access token so we can include it in the authorization header of the request of our API. Usually you will initiate authorization flow in your client application. It can be a React single-page application where a user can see and manage their tasks. However, we don't have this client app. What we can do is to use an extension called Auth0 Authentication API Debugger. I have it already installed, but if you don't, you can just search for it in all extensions and install it. So let me go into this extension. As you can see, it already pulled the domain that Auth0 provided to us. We can choose the application. Let's select the application that we just created called Task Manager App. The Authentication API Debugger has given us a callback URL that we actually need to provide to the Task Manager app. So let's go ahead and copy it, go back to Auth0 dashboard, click on the Task Manager app. Scroll down and in the allowed callback URL, we'll paste the callback URL we just copied and save the changes. Now we can go back to the Authentication API Debugger. We will select Auth0 OIDC tab. We are going to scroll down. There are different settings here, but we are interested in the audience. Audience is how the app knows which API to use. We're going to put the audience for the Task Manager API we just created. So let's go to Auth0 dashboard again, select APIs. We're going to copy API audience and put it in the audience input field of the Authentication API Debugger. We will also toggle Use Audience switch. Now let's click Auth0 OIDC login button. It may take a while, so be patient. It redirected us to the login screen. Now we can just either use login and password if there is a user created in Auth0 or login with Google. Let's click Continue with Google. I'm already authenticated with Google, so it redirects us back to the debugger with a token. Hash fragment is the response you normally would be getting when authenticating your client application. The response has access token, property with the actual token. It also has expires in, scope, state, and token type properties. The debugger provides us with already decoded token in access token section. So let's go ahead and use this token to authenticate a user with our API. When you are validating the token, you want to use the specific library that is suggested by the authentication server. In our case, Auth0 suggests we use Express Auth0 JWT Bear library. Let's go ahead and install it with npm install. We can also check out the documentation for this library. It lists the supported node versions. Library initialization basically creates the middleware. It also suggests environment variables we should use. Let's go ahead and create those environment variables in our .env file. We're going to create issuer base URL and the audience environment variables. The issuer base URL will be the domain URL of the Task Manager app that we just created. The value for the audience will be the audience of the API. In our case, it is Task Manager API that we created in Auth0. Now let's go ahead and add these environment variables to our configuration file. Next, we need to update authenticate user.ts middleware. We can remove all the code we have there and put the following. We're going to import auth from Express Auth0 JWT Bear library, config from config. We create authenticate user variable and assign to it the output of the auth function that is passed audience and issuer base URL configuration options. After that, we export default authenticate user middleware. Next, we'll need to update the error handler middleware to handle errors thrown by Express Auth0 JWT bearer library. But before we do that, if you are learning something new from this video, please like and subscribe to our channel to help YouTube recommend it to more viewers. Let's import unauthorized error from Express Auth0 JWT bearer. In the error handler middleware, we will add another if statement that checks if an error is an instance of this unauthorized error. If it is, we respond with a status code of error.statuscode and send back an error object with error message property and the code if it exists on the error. If not, we will send our own auth code. You can check out Express Auth0 JWT bearer library source code to see what types of error it throws. This library also defines auth property type on Express request. So we don't need to do it ourselves anymore and can delete express.d.ts type definition file. Now let's start the dev server. Let's go to the Auth0 Authentication API debugger and copy the access token. We can now use this access token to test the API. Let's add it to the getTasks request and make a call. Now you can see that we are authenticated. However, no tasks are returned because Auth0 user doesn't have any tasks in the database. Let's go ahead and create tasks for that user. We will copy the value of sub-property from the Auth0 Authentication API debugger and use it to seed the database. We open seed.ts file in Prisma folder and paste the user ID and save the changes. Open another terminal window and run npm run dbseed. The seed command ran successfully. Now we have tasks and projects for this user. Let's go back to the API test.http file and send the request. Now we do have two tasks for this user. We can also use the same token in authorization header to make a call to get projects. The API returns one project. If we make the token invalid by changing letter G to F at the end, we get a 401 unauthorized error response with a message signature verification failed and invalid token code. This proves that the authenticate user and error handler middlewares work properly. That's it for API authentication with Auth0 access token. Now you are set up to secure your Node.js APIs and manage user access effectively with Auth0. Also, don't forget to check out the next video in this Node.js Express series to level up your Node and Express.js skills. Are your Node.js logs messy, hard to read, or missing critical info? In this video, I'll show you how to configure Winston, the ultimate logging library for Node.js. I am in the Node.js and Express app. Let's go ahead and add logging to it. Logging is a critical component of any application. I'm not going to go deep into the reasons why you want to have logging, which may include debugging, monitoring, auditing, error tracking, and traceability. The main thing you have to keep in mind, though, do not log sensitive information such as secrets, passwords, and personally identifiable information or PII. Now, with the warning out of the way, let's go ahead and install Winston library with npm install Winston. Next, let's go ahead and create logger.ts file in src folder. In this file, we're going to import Winston from Winston and config from our configuration file. First, we're gonna define log levels, and the first one with the highest priority will be error, then warning, then info, then HTTP, and finally debug. Next, we will create a constant logger and assign to it Winston's createLogger function. We're going to pass a configuration object to it. The object will include log levels that we just defined, current log level that comes from the configuration, format, where we are going to format errors by logging the error stack. The log format will also include timestamps, and you can format your time however you want. Since I mostly log to the console, I will use printf. We're going to destruct timestamp level, message, log metadata, and stack and put them in the following order. First timestamp, then level, then log metadata if it exists, and then message, and finally, if there is an error, we will log out the error stack. The last step will be to create console transport and add it to the transports array. And speaking of transports, Winston's core transports include console, output to the Node.js console, file, store logs in files, and HTTP, stream logs to HTTP endpoint. Other options include stream, output to Node.js stream, which allows for further customization with the third-party transports like Elasticsearch, Logi, Datalog, or AWS S3. As I mentioned before, I mostly log to console because I deploy my applications to AWS on ECS containers or Lambda function. AWS will automatically take the console logs and port them to CloudWatch. However, if you want to learn how to write your logs to log files using Winston, stick around and I will show you that as well. We are all set. Let's default export our logger. Next, we will open config.ts file and define the log level. The default log level will be info. Now let's try our logger in action and log out some information. We will go to routes, v1, tasks, task controller, and in the list tasks function, we will log out debug message requesting tasks. Let's spin up the dev server with npm run dev and see what we got. We're gonna go to API test.htp file and make a call to get tasks. As you can see, we have get tasks log, which comes from Morgan. However, we don't see our log that says requesting tasks. This is because we logged out the message with a level of debug. However, since we didn't define log level in the environment, the default log level priority is info that we set in config.ts file. And since the debug has a lower priority than info, the requesting tasks message is not shown. In the .env file, let's put the log level as debug. We will also add log level env variable to .env.example file. Let's go ahead and save the changes, restart the dev server, and make a request again. And now you can see that requesting tasks message appears in the console. The way we configured our logger is that we can also add the log metadata. Sometimes you may need to add some additional information to your logs, such as request ID, account, or user ID. Let's go ahead and see how we can use log metadata for that purpose. In the tasks controller file, in the list tasks function, let's create another log message and add user ID to it. To do that, we need to create a child logger and add log metadata with the user ID. After that, we can use this child logger in our function to log out the messages. So let's go ahead and save the changes, go to API test.htp file and make the request again. And as you can see, we now have another log debug statement that says user with ID is requesting tasks. Since we put log metadata before the actual message in printf statement, we got a coherent sentence, but in the real world your log messages will look a little more pragmatic than that. Logging into the console is great, however in some cases you may want to log to a file. If you are going to do that, I suggest rotating your log files. Let's go ahead and install Winston Daily Rotate File Library that will help us to do just that. In the logger.cs file, we will import Winston Daily Rotate file and define a new transport. We will create a variable file rotate transport and instantiate a daily rotate file with the following configuration. File name will be logs application with the date. Naturally, our log files will live in the logs folder. The date pattern property will have a format of the date, zipper archive will be true, max size 20 megabytes, and max files will be 14 days. A transport can also have format property that will override the format we defined earlier. For the file transport, we will also log out error stack, use timestamps, however, instead of printf, we will use JSON. Our file rotate transport is good to go. Let's add it to the logger. One more thing to keep in mind, if you're logging to log files, you don't want to push them to GitHub. Let's go ahead and add the logs folder to .gitignore file to prevent sending it and its contents to the GitHub repo. Let's start the dev server and make another request. In the root of our application, we now have logs folder. Let's go ahead and open application.log file that Winston just created. As you can see, we have the same two log messages that got logged to the console, except for that they are in JSON format. One more thing that I want to show you is how to integrate Winston with other loggers. Sometimes you can use other loggers such as Morgan to log HTTP requests. We're actually doing just that in our application. That get v1 tasks log message is coming from Morgan. But as you may have noticed, this log message doesn't appear to be in the log file and it is formatted a bit differently. Like you can see that it doesn't have the timestamp. In order for this message to appear in the log file or other destinations depending on your transport, and for it to be formatted in the same way as the other log messages, we need to create Morgan middleware to use Winston Logger. We're going to import Morgan from Morgan and Logger from our logger.cs file. We will format the Morgan log message by having the HTTP method, URL, content length of the response, and response time. Next, we will write the message to the stream using the logger with HTTP level. As you may recall, this level is just one step above the debug. So, with the current setting of log level that is debug, the messages with HTTP log level will be also logged out. You don't have to necessarily use HTTP log level for Morgan messages. You can use debug or info or whatever log level you want depending on your requirements. Finally, we're going to export default Morgan middleware. Now let's go to server.ts file. Instead of Morgan dev, we can put Morgan middleware. We will also import it from middleware Morgan middleware and delete Morgan import because we don't need it anymore. Let's start the dev server, go to API test.htp file and make a request. We can see that our request is logged in the same format as other logs with a timestamp in front of it. And if we open the application.log file again, now we can see the log message from Morgan in it as well. If you like, you can play a little bit more with log levels. Let's change the log level in .env file to HTTP. This will prevent debug messages from being logged. We can confirm this by starting the dev server and making a request. Now you can see that only HTTP request is logged. And this is how you can add Winston Logger to your application. Struggling to validate your API requests in Node.js? Meet Joy, the ultimate validation schema library. In this video, I'll show you how to seamlessly implement Joy to handle user input, ensure data integrity, and make your APIs more robust. We will also look at how to use ChatGPT or any other AI for that matter to get a head start on creating validation rules. I am in Node.js and Express API project, so let's go to src routes v1 tasks folder index.ts file. We have routes to list tasks and get task by ID. Let's go ahead and add a route to create a task. Let's call a post method on tasks router and pass the root of the tasks route and the handler function create task as an argument. We will import it from the controller. Create task function doesn't exist yet. Let's go ahead and define it in the controller. Create task will be an async function. It will take request and response. We'll use Prisma to create task. We'll pass the data with a user ID. We'll take the user ID from the token. It will be available on the request auth object. Then we're going to take the body that we received from the user and just spread it out and use it to create a task. And if the task is created successfully, we will return it to the user. However, you can see a problem here because we're not guaranteed that the user will send us correct data to create a task, right? So we need to be sure we validate data that is being sent to the API. Creating validation from scratch is a very tedious job. We need to make sure that the request fields are present, the fields are of the correct type. Sometimes you'll need to have correct combination of fields. Then we also will have to combine all the validation errors and return them back. Obviously, there are NPM packages to help us with all of that. One of those packages is Joy. Let's go ahead and install it with npm install Joy. The best place to validate request data is middleware. Let's go ahead and create validate request.ts file in src middleware folder. We import request, response, and the next function from Express since we're going to be creating a middleware. We're going to import type object schema from Joy, and we're going to do export default function, validate request, and this function will be a higher order function because it will be returning the middleware function. So we'll pass schema of type object schema as parameter, and it's going to return an async middleware function called validator. Validator function will be getting request, response, and next parameters as any Express middleware function does. We will call validate async method on schema with the arguments of request body and a configuration object. Configuration object will have only one option, abort early false. What it means is that if Joy encounters a validation error on one of the properties sent in the payload of the request, it won't bail out. It will continue checking other properties. If you want Joy to bail out early, you can set abort early to true. However, in our case, we would like to return back to the user all the errors, so we will use abort early false. If everything goes well, the method validate async will return a validated payload. We can assign it to the rec body and use it later on to create our task. We want to use this validated payload instead of the body that was originally sent because Joy can do some housekeeping work for us, like trimming strings, converting date strings to JavaScript date object, assigning nulls to an empty fields. All the things we need to do before saving data to the database. However, if validation fails, validate async method will throw an error, but since we have an error handler, this error will be caught and returned to the user. Later on, we will update error handler to target Joy validation errors. If you want to learn more how Joy works, you can go to joy.dev. You can click Get Started with Joy. It will give you the latest Joy API documentation. There is a Getting Started guide, and you can also see right here all the options and all the functions Joy has, and they're pretty extensive. But since we're going to use Joy to validate API requests, we'll use only a small number of Joy methods. Okay, next thing that we need to do is to create the schema to validate the task payload. Since we're passing schema into validate request function, let's go ahead and create that request schema. In src data folder, let's create request schema.ts file and define the schema that we'll need to create a task. We're going to import Joy from Joy, and then we're going to have a const task. It will be an object, and that's where we're going to be doing the validation. So we'll need the field called project ID because tasks can be assigned to projects, and since the task can either belong or not to a project, this project ID is optional. And if project ID is empty, we will assign null to it. And then we can put our own message if validation fails. You don't have to put your own validation messages. Joy will generate them automatically, but I prefer to put messages because I can use a better name for the field and give a user better hints what data is required. For project ID, there will be one validation message. Project ID must be a string. So all these validation rules we're calling on Joy object you can find in Joy documentation. When you are validating a large payload, it can be a little bit of work. However, there is an easier way of creating these validation rules by using AI. So stick around, and later in the video I'll show you how to use ChatGPT to do that. The next field will be name, and it will be a string and will be minimum and maximum character length here. The name will also be a required field. And then we can put our own validation messages for each rule. Alright, next will be the description. Description will allow null, it will be optional, max character limit will be 1000, will allow it to be empty, and the messages will be description must be a string, and description cannot exceed 1000 characters. Next one is a due date. The date should be in ISO format. It should be greater than obviously null. It will be optional. We will allow null and set it to null if it is empty. The validation messages will be due date must be a valid date. The format must be in ISO 8601 and the date should be in the future. Completed on will be similar to the due date except for the constraint will be that it can be greater than null. So we will use joy rule max now. The task object is done. Let's go ahead and define create task schema. It is super easy. We will just call object method on joy and give it the task we just created. Now we can pass create task schema to validate request middleware. So let's go ahead and do that. In the routes tasks index.ts file, we can just go to post method that we defined and we can add validate request middleware and give it a create task schema. And obviously we will need to import both validate request and create task schema. Let's go ahead and run npm run dev. Our API is running. Let's go to API test.http file to test our API. But before we do that, if you are learning something new from this video, please like and subscribe to our channel for more videos like this. In app test.http file, we will add a post request to create a task. We have to be sure to have content type and, since our API is protected, authorization headers. In the payload of the request, we put property hello and value world to trigger a validation error. Then we're going to make this post request, and as you can see, we did get a validation error, but this error has an HTTP code 500 and a message that can be a bit hard to understand. This is how our error handler handled a validation error thrown by Joy. Not bad actually, but we can do better. Let's go to error handler middleware and update error handling to include Joy errors. We will create another if statement where we check if the error that error handler got is from Joy, and if it is, we're gonna create a validation error of type validation error, and the error will be in the following format. We'll have a message as validation error, we'll have code error valid, and an array of error objects. We will just map over Joy error details and extract message from each error detail. Then we'll respond with a status 422 and validation error that we just created in JSON format. Let's do a couple more things. First, we need to import Joy from Joy and then create validation error type. In order to define validation error type, we will write the following code. So we're gonna put a type validation error, and this type will describe the error. We'll have message, error code, and the errors, which will be an array of error objects with a message property. Let's go ahead, save changes, and start the dev server again. I'll go to API test.http file and make a post request. Now we got a better error response. It has 422 HTTP code, and by the way, I think I forgot to mention 422 HTTP code stands for unprocessable entity. The server understands the request but can't process it. Basically, the request is invalid. So 422 should be used for validation error responses. Besides 422 HTTP code instead of 500, we now have error object with a message and the errors array with messages. The task name is required and hello property is not allowed. It looks like validation errors work. Now let's see if our request can pass the validation. So let's go ahead and create a task. We will just use name attribute because this is the only attribute that is required to create a task. Let's send the request, and now we got the task back. So the task got created with a name myTask. Let's go ahead and create another task just to be sure. This time we'll add a due date. In the due date, we will put a date in the future. Let's go ahead and send the request. And as you can see, the second task got created and it has a due date. Besides creating a resource, another common thing that you are going to be doing is updating that resource. So let's go ahead and take a look at how we can update a task because it will work a little bit differently. The difference between creating and updating a task in our case is that when updating a task, we won't require any fields. However, in order for payload to be valid, we will need at least one of the fields to be present. For example, we can just send completed on date to mark a task as completed. In order to validate update task request, we can go to request schemas.ts file and create another schema. Let's go ahead and export const update task schema. It's going to be very similar to create task schema. We will need to update just two things. First, make name optional instead of required, and second, make either one of the attributes necessary to update a task. To make name optional, we will spread task object and then add name property with the joy rules as string, min, and max character constraints, optional, and error messages. To require either one of the attributes necessary to update a task, we can use joy's OR method to pass to it project ID, name, description, due date, and completed on. Now the payload will be considered valid if any of these attributes are present. The validation logic is done. Let's create code to update a task. In index.ts file, in tasks routes folder, we will call put method on tasks router. The route will be /ID parameter because to update a single task, we will also need to know its ID. We call validate request middleware with an argument update task schema and use update task handler. Let's import update task schema from the request schema. Also, let's import update task handler from the controller and create it. In the controller, we'll export function update task. Update task will be very similar to create task. We will use Prisma update method. When updating a task, we need to know which task to update, so we'll have a where property with the task ID, which we get from request params. In the data property of Prisma update configuration, we will just spread out reg.body since it contains already validated attributes. Therefore, it is safe to pass them to Prisma. If the task is updated successfully, the API will send the updated task back to the client with response status 200. And while we add it, let's change response status to 201 from 200 in the response of create task function, because 201 HTTP status code stands for created, therefore it is a better code to use when creating a resource. Let's start the server with npm run dev. In API test.htp file, let's create put request to update a task. We also need to get a task ID and put it in the request. In the payload, let's try to update the task name to updated task and send the request. The task was successfully updated. Let's also try to complete this task by setting completed on to a date in the past, and now the task has completed on value as well. Finally, let's assign this task to a project. Let's grab a project ID from get projects endpoint. We will use the project ID to update the task using put request. And now our task is assigned to a project. Speaking of projects, when creating a project or updating a project, we will also need to validate data sent by the user. Let's take a look at Prisma schema. According to Prisma schema, we will need only two fields, name and description, to create a project. And of course, we will need to validate them. Obviously, validating those properties is going to be easy. However, in real life, resources can have a lot of attributes and validating them can be a little bit of work. And that's where you can use AI to help you create joy validation rules. Let's go to ChatGPT and do the following prompt. Create joy project validation schema to create a project. Project is an object. Name my project. Description my project description. Name is required. Description is optional. When defining an object for ChatGPT or other AI tools for that matter, I'm using ChatGPT as an example. You can use an example payload so the AI based on the example will figure out validation rules. And of course, you can add clarifications, in our case with old ChatGPT, that the name should be required and the description should be optional. ChatGPT created joy validation rules for us and, frankly speaking, did a pretty good job. It also suggested we should be trimming the strings. It is a good idea because sometimes users can put in extra spaces at the end when entering data. You can use the rules generated by ChatGPT as a basis for your validation schema and tweak them the way you need. So AI provides a great head start for creating validation logic. Struggling with the messy import paths in your Node.js projects? In this video, we will unlock the power of TypeScript path aliases to make your code cleaner, more readable, and easier to maintain. I am in Node.js Express project and our project has been growing. So if you go to Routes v1 Tasks Controller, we can see that we have imports coming from deeply nested modules. You can see ... Our imports have many dots. On one hand, it doesn't look real pretty, and on the other hand, if we were to move this controller file to a different folder, we will have to update all these imports because they are relative. Of course, VS Code will help us do this refactoring, however, we will still have to check it. Another approach is to use TypeScript path aliases. With aliases, we can just point to the src folder with @ symbol and our import path will collapse to @/errors, @/prisma client, and @/logger. However, you can see now we have the imports underlined in red because TypeScript doesn't understand it. Let's go to tsconfig.json file and update it so the errors go away. In compiler options, we first need to define base URL. And this base URL will be just a dot, the root of our project. After base URL, we add paths configuration, and this will be an object where we define aliases. We're gonna put @and/star, and it will be pointing to src/star, the files in the src directory. Alright, let's go ahead and save the changes, and now you can see the errors went away. So TypeScript now understands the aliasing. Although TypeScript understands the aliasing, the Node.js actually doesn't. And if we build and run this project, the Node.js is gonna start complaining. Let's go ahead and build a project. We will need to create a build and run scripts. Let's go to package.json and define build script. Build script will just run tsc command to compile TypeScript into JavaScript. In the start script, we will use .env to import environment variables from .env file, and we will use node command to run index.js file in the dist folder. Also, since we're going to be building in this directory, we're going to include this directory in a .gitignore file so it doesn't get committed to the repository and pushed to GitHub. Let's go ahead and save the changes, and instead of npm run dev as we usually do, let's run npm run build. Our build has been completed. Now we have the dist folder. Let's go ahead and run command npm run start to start the application. As you can see, we've got a problem here, right? It tells us that Node.js actually cannot find module @/errors. So TypeScript understands the import path, but Node.js doesn't. Let's go ahead and fix that. In order to fix the issue, we need to install a package called module alias. Let's go ahead and type npm install module alias. And we also need to install the types for module alias with npm install @types module alias with a save dev flag. Next thing that we need to do is to go into package.json and add configuration for module alias package. At the bottom of package.json file, we're going to put _module aliases configuration object, and we're gonna put @ symbol, and it will point to the dist folder. Finally, we will need to import module alias register into the index.ts file. So let's go to index.ts file, and at the very top of the index.ts file, we'll just do import module alias/register. Now we should be good. Let's go ahead and rebuild the project with npm run build and npm run start. And as you can see, our API is running on port 3000 and aliases are being resolved by Node.js without a problem. If you feel like you are learning something new from this video, please like and subscribe to our channel for more videos like this. Now let's go ahead and start the development script with npm run dev. And it looks like everything is great here as well. However, if we delete the dist folder and run npm run dev again, we're gonna have an issue. Because we're using tsnode and tsnode compiles TypeScript files on the fly, it doesn't create a dist folder. So the module alias package that we installed won't work. We can go ahead and try to find a fix for tsnode so it understands path aliases. However, we're not going to do that. Instead of tsnode, we can actually use a different package to run our app in development. In package.json file in the scripts, we have a dev script which is running nodeman. And if we look at nodeman.json file, we can see the configuration that basically runs tsnode. Let's go ahead and use a different package instead of tsnode. Since we're building our project with a tsc, we can also use tsc to run our project in development. The package that will help us automatically restart our project in development is called tsc watch. Let's update the dev script with a tsc watch. We will inject our environment variables with a .env and on success run node dist/index.js file. When in development, tsc watch will be rebuilding application and will be creating or updating files in the dist folder. So we should be okay there because we have the module aliases that will be applied to the files in dist folder. And if you go and look at the npm documentation for tsc watch, right, it builds itself as a nodeman for TypeScript. The docs have some other tsc watch options that you can explore. But we will go back to the project, and since, tsc is a nodeman for TypeScript, we can actually go ahead and remove the nodeman from our project. And we can also remove tsnode as well. Let's go ahead and uninstall the packages with npm uninstall nodeman and tsnode. We can also remove the nodeman.json configuration file. And now instead of these two packages, we can just install tsc watch with a dev flag. Alright, our app is good to go. Let's go ahead and save the changes, run npm run dev, and as you can see now, the app is running in development using tsc watch. Now the path aliases work both when we build our project and when we develop it. The final thing that we actually need to fix is our tests. So if we go to add.test.cs file, we have an import from utils here, so we can put add/utils instead of utils, and it looks like TypeScript understands it in the test with no problem. But then if we run npm run test, we will get the same issue. It tells us that it cannot find module at utils. So we need to update jest.config.mjs file to make jest understand the path aliases as well. In order to fix the jest, let's do the following. We're going to import path to module name mapper from tsjest. Path to module name mapper basically will map the paths that we created in tsconfig file to modules. So at utils will be mapped to src utils. Then we're going to import create require from modules. Since ES module do not support require directly, we will use create require to load the tsconfig.json. We will destruct compiler options from tsconfig and use compiler options base URL for module paths option in jest configuration. Then we will assign to module name mapper config property path to module name mapper function and pass to it compiler options paths and config object with a prefix rootdir/option to correctly map module paths relative to the jest root directory. This ensures jest resolves paths accurately. Let's go ahead and save changes and run npm run test again. And now we can see that jest also understands the path aliases. Great. When using path aliases in your TypeScript projects, there are a few things to keep in mind. First of all, you gotta be explicit and descriptive. Your path alias names should clearly represent contents of the directory or the module alias. For example, add components instead of add C, to define alias for components stored in components directory. Also, you have to be consistent. You have to maintain a consistent naming convention for your paths aliases through the project. For example, if you use @components, stick to similar naming pattern like @utils or @API. Avoid collisions. You have to ensure that your path alias doesn't clash with the names of installed packages in Node modules directory. It's good practice to always use unique names for your path aliases to prevent such conflicts. Also, you should consider the size and complexity of the project. Path aliases could potentially lead to overhead. For a smaller project with a very limited number of modules, a path alias might be not needed. For example, our project is actually not that big, right? It should be okay without path aliases. The only reason I'm using path aliases is to show you how to do them. Finally, ensure that any tooling you use in your project is compatible with the path aliases to prevent any potential errors during development. And you basically witnessed it when we had to swap TS Node for TSC Watch. In tsconfig.json, we defined the path to the src directory, but you can actually create path aliases to any folder you like. Let's try doing that. Let's add a path alias to errors, and this will point to src errors. We will put the star at the end to include everything in the errors path. Now we can go ahead and go to the tasks controller file and use @errors to import errors instead of @/errors. And TypeScript will understand what we're pointing to. But again, keep in mind, you will need to actually update the module aliases configuration in your package.json file to add path for errors. So @errors will point to dist/errors. Alright. Now, if we run npm run dev, everything still works because we're pointing to the errors folder correctly. And again, like I mentioned before, when you do your path aliasing, be sure you don't collide with npm packages because many npm packages start with @symbol. For example, @Prisma. Some people use tilde or squiggly line instead of @symbol in path aliases to avoid collision with npm modules. I hope you understand the aliasing a little bit better now, and it is not just simply going into tsconfig file and adding path configuration to the compiler options. You also need to consider how your aliases will affect Node when running JavaScript files in production. Also, if you are using Jest for testing, you need to be sure it understands path aliases if you are planning on using them in your tests. Finally, your dev workflow may also need to be adjusted. Do you want to implement clean, scalable, and maintainable architecture for your backend? In this video, we'll explore how to use the repository pattern with a TypeScript to achieve clean architecture in your Node.js applications. By the end, you'll understand how this design pattern decouples data access, keeps your code base flexible, and aligns with industry best practices. I am in Node.js Express project. This is a task manager API. Let's take a look at the code that returns the tasks. In routes v1 task folder, index.ts file has routes to list tasks, get task, create and update task. The handler functions for the routes are in the controller.ts file. The project routes and the project controller are structured in the same way. The route handlers, be they in the tasks or projects controller, access database directly using Prisma client. Although simple, this design presents a few problems such as tight coupling, reduced testability, and scalability issues. Let's fix these problems by introducing a repository. Before we start coding, let's take a look at what we're actually going to implement. The current state of the application is such that tasks and projects controllers have Prisma ORM as a direct dependency. By creating a repository, we will remove this dependency. At the heart of the repository pattern lies an interface. This interface is a contract that ensures that the repository will provide a set of specific methods and specific outputs to the controllers or client code in general. Now, instead of having a direct dependency on Prisma ORM, tasks and projects controllers depend on the interface. This interface is implemented by Prisma repository that has Prisma ORM as a dependency. Now, if we decide that we don't want to use Prisma ORM and use SQLize or NoSQL database, all we have to do is create a SQLize or Mongoose repository that implements the interface. No changes to controllers are needed. And as you can imagine, large projects have a lot of controllers, so repository pattern can potentially save us a huge amount of work if we decide to make changes to how our application accesses data. Now let's take a look at how we're going to implement the repository. We're going to use TypeScript mixins with inheritance. On one hand, this approach provides simplicity. The client code just has to import the repository and call appropriate methods. On the other hand, it provides separation of concerns. Each mixin is designed to handle a specific entity, project, or task. Since both mixin repositories extend the base repository, they inherit its functionality, enabling efficient code reuse and adherence to the dry or don't repeat yourself principle. Very much like Russian dolls, the mixins and the base repository are combined into a single repository that is instantiated and imported in the client code. Now that we know what and how we're going to be building, let's create some code. But before we do that, if you are learning something new from this video, please like and subscribe to our channel for more videos like this. We're going to create repository.ts file in src data repositories folder. This file will contain interfaces. Let's put the following code in there. We will export iTask interface. It represents a task in the system with various properties that describe its attributes. And the properties are ID, unique identifier, user ID, the ID of the user to whom the task belongs, project ID, the ID of the associated project, name, description, due date, the due date for the task, completed on the date when the task was completed, and created at the date when the task was created. iProject interface represents a project in the system with the properties that describe its details. And they are ID, unique identifier for the project, user ID, the ID of the user who owns the project, name, description, and created at the date when the project was created. As you can see, these interfaces mimic the database structures for task and project except for leaving off updated at fields. Next, we will define query parameter interfaces. We will need them for listing tasks and projects. iQuery parameters interface serves as a base interface for query parameters. It has the following properties: limit optional, a number specifying the maximum number of results to retrieve, an offset also optional, a number indicating the starting point in a collection for pagination. As you may have guessed, later on these properties will be used for pagination. iTask query parameters interface extends iQuery parameters, inheriting its properties. It adds properties specific to task-related queries. For now, it is just one: project ID, which is optional, a string representing the ID of the project to filter task by. Later on, we will add other properties to be able to filter tasks by due date and completed on. iProject query parameters interface extends iQuery parameters, inheriting all its properties. This interface does not add any properties for now. In the future, we may add specific properties to be able to filter projects as well. Finally, let's define interfaces for task and project repositories. iTask repository interface represents a repository for managing task-related data. It has methods listTask that retrieves a list of tasks based on the query parameters, optionally filters tasks for a specific user ID, and returns a promise that resolves to an array of iTask objects. GetTask fetches a single task by its unique ID, optionally ensures the task belongs to a specific user ID, returns a promise resolving to an iTask object. CreateTask creates a new task using the provided partial task data payload, optionally associates the task with a specific user ID, and returns a promise resolving to a newly created task object. UpdateTask updates an existing task identified by ID using the provided partial task data payload, optionally ensures the update is performed for a specific user ID, and returns a promise resolving to the updated iTask object. iProject repository represents a repository for managing project-related data. The methods are list projects, retrieves a list of projects based on query parameters, optionally filters projects for a specific user, and returns a promise resolving to an array of iProject objects. GetProject fetches a simple project by its unique ID, optionally ensures the project belongs to a specific user ID, and returns a promise resolving to iProject object. With interfaces defined, let's create repositories. We will start with a base repository by creating a base repository.ts file in src data repositories folder. The base repository will contain the following code. We will import Prisma client from @Prisma client and export default base repository class. This class acts as a base class for other repository classes. It provides default query parameters, default limit, and default offset that can be used for database operations, and it also initializes a Prisma client. It has a getClient method that returns the Prisma client instance. This method is useful if external code needs access to Prisma client. Base repository file also exports a constructor type. This is a utility type that is used in mixins pattern. It has a generic type parameter that defaults to an empty object, and a constructor function that accepts any arguments and returns an instance of type T. If you would like to learn more about TypeScript mixins, check out TypeScript Handbook. It explains how mixins work and how to create one. Alright, it looks like ESLint is complaining about an empty object type and explicit any. Let's go ahead and fix it by turning off these rules in eslint.config.mjs file. Now let's create @task repository.ts file in the same src data repositories folder. We will import entity not found errors from @errors entity not found, base repository, and constructor from base repository, Prisma from @Prisma client, iTask, iTask query parameters, and iTask repository from repository. We will also define Prisma task type that represents the raw database payload for a task entity retrieved using Prisma. @task repository function is a mixin function that takes a base class tbase and extends it with task-related methods. It returns a class task repository mixin that implements the iTask repository interface and provides methods for querying, creating, updating, and mapping tasks. MapTask method converts a raw Prisma task object into an iTask object for consistency across the application. ListTasks method retrieves a list of tasks from the database. It supports filtering by user ID and project ID with optional limit and offset for pagination. If limit and offset are not present in the task query parameters, the default values are used from the parent base class. ListTasks returns an array of mapped tasks. GetTask method fetches a single task by its ID and user ID. It throws an entity not found error if the task is not found. This entity not found error will be handled by error handler that we created earlier. If you want to learn how to do it, please check out the video about error handling in Express application. It returns map task. Create task creates a new task in the database, uses user ID and the provided payload for the task data, and it returns the map task. Update task updates an existing task by ID and user ID, accepts a partial iTask object as the update payload, and returns the map task. Now let's define project repository by creating @project repository.cs file in src data repositories folder. We will import entity not found error from @errors entity not found, base repository and constructor from base repository, Prisma from a Prisma client, iProject query parameters, and iProject repository from repository. We will define Prisma project type that represents the raw database payload for a project entity retrieved using Prisma. We are going to export add project repository function, a higher order function that takes a base class T base and returns a new class project repository mixin with a project related functionality. Map project method converts a raw Prisma project object into iPrisma object for consistency across the application. List projects method retrieves a list of projects belonging to a specific user. It supports pagination using limit and offset query parameters and returns an array of mapped projects. GetProject method fetches a single project by its ID and user ID. If the project is not found, it throws entity not found error and it returns a mapped project. Now let's combine all the mixins that we just defined into a single repository class. Let's create index.ts file in src data repositories folder. We will import base repository, add task repository, and add project repository. We're going to use function composition or the chaining of functions to create an instance of repository and export it. We're all set. Now let's go ahead and update the code in the controllers to use the repository. In tasks controller, we will just leave request and response imports from Express. Instead of all other imports, we will import a repository from add data repositories. Inside the list tasks function, we will use repository list tasks method, passing to it an empty object for now. Later on, we will add more properties to it to filter tasks, and user that we get from rec auth payload sub. This property comes from a parsed authentication token. GetTask function will use repository getTask method with a task ID coming from request parameters and user ID. CreateTask function uses repository createTask method and takes validated request body and user ID. UpdateTask function uses repository updateTask method that takes task ID to be updated, validated request body, and user ID to ensure only user that created the task can update it. Now let's go to projects controller. We will remove all the imports except for request and response import from Express, and we will import repository from add data repositories. List projects function will use repository list projects method and pass to it an empty query object and a user ID. Again, later this empty object can be used to filter projects. GetProject function will use repository getProject method and pass to it project ID coming from request parameters and user ID to ensure the project belongs to the user. Finally, in list project tasks function, we will use repository list tasks method with a project ID as a query parameter and user ID as the second argument to ensure that the tasks also belong to the correct user. We're all done. Let's start the project with npm run dev and quickly check if everything still works. We'll go to API test.htp file, get task endpoint still returns the tasks belonging to the authenticated user. Get projects endpoint also works as well. Looks like the refactoring to repository pattern was successful. Struggling with pagination in your Node.js REST API? Offset pagination can simplify fetching data for your users while keeping your backend efficient and scalable. In this video, I will break it down step by step, showing you how to implement it seamlessly. When presenting information to a user, such as a list of tasks, orders, or products, you don't want to show thousands of them at a time, because on one hand, it is not a good user experience, and on the other hand, it may be inefficient to retrieve all the records from the database in one go due to memory constraints. A better way is to break down data into small manageable chunks or pages. Offset pagination is a commonly used approach. Let's take a look at how it works. From the client perspective, the client needs to request a page that it wants to show to a user and a number of records per page. On the server side, an API needs to convert page and per page to limit and offset for the database to understand. Page becomes a limit or a number of records to retrieve, and per page multiplied by page minus 1 becomes an offset, a number of records for the database to skip before retrieving the requested records. After the records are retrieved, the API sends them back to the client. However, for the client to correctly display pagination, it needs one more piece of information: the total number of records. The total number of records is needed to calculate the number of pages. Since the client already knows how many records per page it is requesting, it can divide the total number of records by records per page and round it up to the next whole number. Since the server also knows the total number of records, sometimes it is better to provide pagination information back to the client in the response, so the client can just simply pass it to the pagination component. We will do just that. Since now it is clear how the offset pagination works, let's go ahead and implement it. I am in a Node.js Express project. What we're building here is a task manager API, and as usual, the link to the code for this video is in the description below. Earlier, we implemented a repository pattern to abstract data retrieval. Let's go to src data repositories folder. In the repository.ts file, we defined interfaces. Let's go ahead and add 2 more interfaces. We will export iTask query result interface that will have the task property, an array of iTask objects, and total count property, a number. In the similar way, we will define iProject query result interface with a project's property of an array of iProject objects and total count property, a number. We also need to modify the list tasks and list projects method in the iTask and iProject repositories to return the iTask query result and iProject query result respectively. Now let's update the actual task and project repositories to comply with the changes. But before we do that, if you are learning something new from this video, please like and subscribe to our channel for more videos like this. In add-task repository.ts file, we will import iTask query result from repository. We will update list tasks method to return type to be iTask query result instead of an array of iTask. In list tasks method, we will define a variable where and assign it to an object with a user ID and project ID properties. Instead of task find many method called on Prisma client, we will use a Prisma transaction. This transaction will wrap task find many and task count methods called on Prisma client. To be consistent in querying and returning tasks find many and count, we'll use the same where object that we defined earlier. Take and skip properties on find many will be assigned limit and offset coming from the query object respectively. Finally, instead of simply returning tasks in list tasks method, we will return an object containing mapped tasks and total count, complying with the iTask query result interface. In add-project repository.ts file, we will make similar updates. We will import iProject query result interface from repository. We will update list projects methods return type to be iProject query result instead of an array of iProject. In list projects method, we will define a constant where that is an object with a user ID property. Instead of project find many, we will use Prisma transaction to call find many and count methods on project passing where object and using take and skip to account for limit and offset. We will return an object with a projects and total count properties complying to iProject query result interface. Now we need to update tasks and projects controllers to get limit and offset from pagination parameters and also return tasks or projects to the client with a pagination metadata. Since we will need to get limit and offset from query parameters for both tasks and projects, let's create a utility function getPaginationParameters to avoid code duplication. In utils.ts file, we export getPaginationParameters function. It will accept rec and express request as a parameter. No pun intended. In the function, we will parse the page and per page query parameters from the request. We will validate the parsed values to ensure they are valid numbers and greater than 0. If the per page is not specified or less than 1, we will assign a default page size value from the config object. We will calculate the limit, number of items per page, and offset, number of records to skip, based on the validated page and per page values. And we will return the computed pagination parameters, page, per page, limit, and offset. Finally, at the top of the utils file, we will import request from Express and config from config. And speaking of config, let's go ahead and define default page size property on the config object in config.ts file. Now we are ready to update the code in the controllers. In the tasks controller, we will import get pagination parameters from utils. In the list tasks method, we will destruct page, per page, limit, and offset from get pagination parameters function, calling it with express request as an argument. We will call repository list tasks method with calculated limit and offset. Finally, we will send a response containing tasks, page, per page, total pages, and total count properties. In the projects controller, we will also import get pagination parameters from utils. In list projects function, we will destruct page, per page, limit, and offset from get pagination parameters function. We will call repository list projects method, and after we get the result, we will respond back to the client with a JSON containing projects, page, per page, total pages, and total count of the projects. In the list project tasks method, we will follow a similar approach. However, in addition to using the calculated limit and offset from get pagination parameters, we will include the project ID from the request to retrieve tasks associated with a specified project. The response will be the same JSON object structure as in the list projects function. We are all set. Let's check if the code works. Let's start the dev server with npm run dev and go to API test.http file. Let's update get tasks request with the query parameters per page equals 4 and page equals 2. After making a request, we receive a response containing not only tasks, but also pagination metadata specifying the requested page, number of records per page, total pages, and total count. Let's also make a call to get projects. This time we won't add any query parameters. Although current user only has one project, the response will contain pagination metadata with page defaulting to 1 and per page defaulting to 5, the number of default per page results specified in the config. As you can see, it is fairly easy to implement offset-based pagination in the context of an API. Compared to cursor-based pagination, offset pagination has several advantages. For instance, you can jump to any page immediately. You can skip 200 records and take 10, which simulates jumping straight to page 21 of the result set. This is not possible with a cursor-based pagination. You can paginate the same result set in any sort order. For example, you can jump to page 21 of a list of user records sorted by first name. This is not possible with a cursor-based pagination, which requires sorting by a unique sequential column. However, cursor-based pagination has an advantage over offset pagination when number of records is large. For example, if you skip 200,000 records and take the first 10, the database still has to traverse the first 200,000 records before returning the 10 that you asked for. This negatively affects performance. Is your API struggling with pagination? Are your queries getting slower as your dataset grows? Offset pagination might be the culprit. In this video, I'll show you how to implement cursor-based pagination, a faster, more efficient way to handle large data sets in your REST API. Let's take a look at how cursor-based pagination works. When a client needs next or previous page, it sends a request to the server specifying next or previous cursor and optionally a page size. The server parses query parameters to determine limit and cursor, a starting point for traversing the records in the database. After the records are retrieved, the server sends back to the client the result, and if there are more results in the database, next or previous cursor or both. The client's job is pretty easy. It shows next and previous pages buttons depending on the cursors it receives in the response. On the server side, however, the job is a bit more complex, because in addition to retrieving the data, it needs to determine the cursors. Cursor-based pagination can only work on sequential columns, such as ID or a timestamp. Also, the order of the records is important. Let's assume that we need to present records to a user in an ascending order. So if we need to paginate forward, retrieving the next page, the ascending order should be used. When querying the database for the next page, we need to make sure we're taking one more record than we need to determine the new next cursor. If the number of retrieved records is greater than the limit, that means we have more records. We will discard an extra record and assign the last record in the set to be the new next cursor. When retrieving the next page, we will get records that are greater than the next cursor. If we are retrieving records using the next cursor, that also means we have a previous page. So the first record in the retrieved result set will be the previous cursor. In order to get the previous page, we need to arrange the records in the reverse order and get the records that are less than the previous cursor. We will also get one more record than we need to know if we can paginate back even further. We will discard that extra record, assign new previous and new next cursors if needed, and reverse the order of the retrieved result set so we can present the records in the correct order to the user. That's a lot. Let's take a look how to implement it in the code. I am in Node.js Express project. This is a task manager REST API that has tasks and projects as main entities. Tasks and projects in our application have CUIDs or collision-resistant unique IDs. CUIDs are not sequential. A sequential column in our database is created at, that is a timestamp. Therefore, we will use created at as a cursor column. In one of our previous videos, we introduced repository pattern. Let's go to repository.ts file in the src data repositories folder and update iQuery parameters interface to include next and prev cursors instead of the offset. We will also create iTest query result and iProject query result interfaces that include next and previous cursors. Now, instead of returning arrays of tasks and projects, list tasks and list projects methods should return iTest query result and iProject query result types, respectively. Now we need to update the actual implementation of these methods to comply with the interfaces. When implementing cursor pagination, we need to do three things. First, we need to determine cursor, if any, sorting order of the cursor column, in our case created at column, and direction for the pagination. We're going to take records that are greater or less than a cursor. Next, we need to fetch records from the database with applicable limit and order. And finally, we need to determine new next and previous cursors, if any. The logic for the first and the last step is the same for any entity, whether task or project. Therefore, we can use power of interfaces and put this logic in the parent class so both task and project repositories can reuse it. Let's go to base repository.ts file and define the logic. We will create a protected method getPaginationQueryParameters. This method will check if query has limit and cursor and determine sort order and operator. Greater than to take records after the cursor or next page, or less than to take records before the cursor for the previous page. Another protected method that we defined is getPaginationCursors. We will use this method after we fetch the records from the database to determine new next and previous cursors based on number of records we fetched, sort order, and existence of next or previous cursor that was already used to fetch the records. The logic can be refactored to look better, but I will leave it the way it is so it is more clear. One more thing to note is that after we determine that we have more results, we get rid of an extra record that we fetched. Finally, let's go ahead and update import from @Prisma client to import both Prisma and Prisma client. We will also import iQuery parameters from repository, and we also need to be sure iQuery parameters is actually exported from repository.ts file. Now we can update task and project repositories to use fetch records and use these methods. In the add task repository.ts file, we will import iTaskQuery result and set it as a return type for listTasks method. In the listTasks method, we will remove the existing code and put the following. We will destruct limit, sort order, operator, and cursor from the output of getPaginationQueryParameters method. We will define where variable that will contain user ID to fetch tasks belonging to the user project ID in case we are requesting tasks for a specific project, and create a dat that can be greater or less than the cursor. We fetch tasks with already determined where, limit, that is one more than we need, and sort order. We call getPaginationCursor method to determine new next and previous cursors. Next, we check if sort order is descending, meaning we're going backwards to fetch a previous page. If so, we reverse the order of the fetched results. Finally, we return mapped tasks and new next and previous cursors, if any. In add project repository, we do the same thing. We're going to import iProjectQuery result and set it as a return type for listProjects method. We will update code in listProjects method to do basically the same thing that we did in the listTasks method and return mapped projects, next and previous cursors, if any. Next thing that we need to do is to parse per page and next or previous cursor from the request query string and call listTasks and listProjects method with the appropriate query argument. Since parsing pagination parameters from query string is logic that will be used in both tasks and projects controllers, we can define it in the utils file. Also, it is a good idea to base64 encode the cursors, in our case the timestamps, when returning them back to the client. So in utils.ts file, let's first define encode base64 and decode base64 functions. Next, we will define getPaginationParameters function. It will take express request as a parameter, no pun intended. It will determine and validate limit based on per page query parameter and next and previous cursors that will be decoded from base64 if present. We will also import request from express and config from config. In the config, we need to define default page size, since we use it as a fallback in getPaginationParameters function during validation. Now we can use getPaginationParameters in tasks and projects controllers. Let's go to tasks controller. We will import encode base64 and getPaginationParameters functions from utils. In the listTasks function, we will call getPaginationParameters with a request as an argument. We call repository listTasks method with the destructed output from getPaginationParameters function. Finally, we will return the response back to the client containing the tasks from the listTasks methods result and base64 encoded next and previous cursors. In project controller, we'll do the same. We will import encode base64 and getPaginationParameters from utils. In the listProjects function, we will call repository listProjects method with a query object containing the outputs of getPaginationParameters utility function, and return the response to the client containing projects and base64 encoded next and previous cursors, if any. Finally, in projects controller, we will also need to update listProjectTasks method so it also returns paginated results for the tasks belonging to a specific project. We are all set. Now we can test our work. In API test.htp file, let's make a request to get tasks with a query parameter per page equals 3. As you can see, we got the first 3 results with the next cursor. Let's use this next cursor to request the next page. Now we got both next and previous cursors, since there are more results going forward and we also have a previous page. Let's now use a prev cursor as a query parameter and make a request again. You can see that we got the first page, so our code works. As you may have noticed, cursor-based pagination takes a little bit of work to implement. And we only did the easiest case where we have a predefined or hard-coded cursor column and predefined sort order. In certain cases, the requirement may be to let user choose sort order. Then in your code, you need to dynamically decide which order is the forward one, ascending or descending. In our example, the forward one was ascending. Another complication can arise if the requirements are such that users should be able to sort using different columns, like updated at or processed at. In that case, not only the order becomes dynamic, but also the cursor column as well. In addition to that, it is a good idea to index your cursor column, unless it is a primary key, since it will be sorted. In our case, we should index created at if we're expecting to have a really large number of tasks or projects. Finally, you can run into situations where a cursor column, although sequential, can have duplicate values. This can cause incorrect pagination behavior, where records might be skipped or duplicated across pages. The solution is to use an additional typebreaker column, such as ID. So you will have to sort by both created at and ID, and your cursor will be the values of created at and ID together. You can separate them by a pipe or underscore before encoding to base 64. In this video, I'll show you how to implement search, sort, and filter in your REST API using Node.js and Express, so your API delivers exactly what users need when they need it. Let's take a look at how search, sort, and filter works. A client makes a request to the API, usually passing search, sort, and filter parameters in the URL query string. On the server side, the API parses the query string and converts it to where and order by conditions to query the database. Where and order by depends on which ORM or object relational mapper you are using. So you have to check the documentation to correctly construct the conditions. In our case, we will be using Prisma ORM. Let's go ahead and jump into the code and implement search, sort, and filter in the API project. I am in Node.js Express project. This is a task manager API. We're going to update get tasks request to be able to search tasks by name, filter tasks based on completion, and sort them by created at and a due date. Earlier, we implemented repository pattern. So we're going to start by updating repository interfaces. Let's go to src data repositories repository.ts file. Here we defined iTask query parameters interface. Let's update it with the optional search, completed, and order by properties. Search is a string, completed is a boolean, and order by is an object with a key created at or due date and the value ascending or descending. It is always a good idea to limit the fields you allow users to search or order against, because when you have a lot of data in the database, you will need to index those fields so the queries run faster. Too many indexes is never a good idea because they slow down writes to the database. In our case, we are limiting sorting by created at and due date. Later, you will also see that we will be searching only task name and not task description. In add_task_repository.ts file, let's update list_tasks method. We will type where object as Prisma task where input and add name property that is an object that contains query search. If your project is small, you can update the Prisma's where condition to search through descriptions as well. However, if the project has a lot of data, this will require introducing a full text index. You will also have to use a different syntax in your query, so you will need to check with your ORM. If the query requirements for your project are so that users should be able to search through a lot of different fields, you should check out Algolia search engine. Even if you don't have extensive search requirements for your project, check out Algolia anyway. It's pretty cool. Next, let's update where to filter tasks based on completion. It is a bit tricky because we don't use boolean to denote if the task is completed, but rather a date when it was completed. Also, if completed filter doesn't exist on the request query parameters, we need to return all the tasks. So first we need to check if completed property exists on a query. Basically, if it's not undefined. If it exists and it is true, we use syntax to get tasks where completed on is not null. If completed is false, we get tasks where completed on is null. Finally, we need to update tasks find many to use order by. Since we structured it the same way the Prisma uses it, we just need to assign query order by to order by property. We're all set. Now we need to parse search, sort, and filter query parameters and update controllers list tasks method to use them. But before we do that, if you are learning something new, please like this video and subscribe to our channel for more videos like this. Let's go to utils.ts file and create parse task query parameters function. This function will take the express request as a parameter and return iTask query parameters type that we defined earlier. So we will need to not to forget to import it. We will destruct search, completed, and order by from request query. Next, we will add logic to determine completed. For sorting the query parameter, we'll use a hyphen or dash to separate order by field and its direction, resulting in a format like created at dash descending. We will make sure to only accept order by if it is created at or due date and the order is ascending or descending. Finally, we will return an object containing search, completed, and order by properties. At the top, let's also import interface iTask query parameters from repository. Now let's update the code in the tasks controller. We will import parse task query parameters function from utils. In the list tasks function, we will call parse task query parameters, passing the request as an argument. The return task query parameters will then be added into the query object for the repository list tasks method. We're all set. Let's spin up the dev server by running npm run dev. In the API test.htp file, we will update getTasksRequest method with a search equals task to search for tasks that contain word task in their name. We will get back the result that satisfies this condition. Let's narrow the query by adding completed equals 0 and order tasks by created at descending. The returned results also satisfy the conditions. None of them are completed and they are ordered by created at descending. Looks like the code we added to search, sort, and filter tasks works. Debugging TypeScript code can be a nightmare. Ever seen cryptic error messages pointing to compiled JavaScript? That's where source maps come in. In this video, I'll show you how to enable source maps, making debugging easier and more efficient. Source maps in TypeScript are files that bridge the gap between the compiled JavaScript code and the original TypeScript source code. They enable developers to debug TypeScript code in environments where only the compiled JavaScript is executed, such as web browser or Node.js. I am in Node.js Express project that uses TypeScript. TypeScript files are compiled into JavaScript files using TSC and TSC watch during development. Let's go ahead and trigger an error. In server.ts file, in get health route, let's throw an error with the message oops. Now let's start the dev server with npm run dev, go to API test.htp file and make a request to the health route. As you can see, we got an error stack logged out in the console. However, the top of the error stack shows a compiled.js file instead of the .ts file where we threw the error. For smaller projects, it may not matter much, but if the project is fairly large, mapping the error manually to the corresponding .ts file can be very tricky. Let's go ahead and enable source maps so the error stack shows TypeScript files instead of the JavaScript ones. In tsconfig.json file, let's add source map true to the compiler options. Now let's go to package.json file and add enable source maps flag to the dev script when running Node. And that's it. Let's restart the dev server. Now if we make a request to get health endpoint again, we get an error stack with a server.ts file instead of server.js file. We can click on that file and see exactly where the error occurred, or if to be exact, where we threw it. If we look in the dist folder, we can see that besides the JS files, there are also JS map files. These files enable mapping from compile.js files to the corresponding TypeScript files. So for each JS file, we also have a js.map file. One can argue that when running the app in production, those files bloat the source code. However, errors do happen in production and the ability to effectively trace and fix them is important. So the larger code base has to be the necessary evil, so to speak. But if you would like to turn off source map when deploying to production, it's not really possible to override the source map option in a tsconfig file. Instead, you can use a more flexible approach by using source map flag with a tsc command. Let me show you how to do that. But before I do it, if you are learning something new, please click the like button and subscribe to our channel for more videos like this. In tsconfig.json file, we will remove source map true from the compiler options. In package.json file, we will add source map flag after tsc watch command in the dev script. Let's stop the dev server and remove dist folder with rm-rf dist command. Now let's start the dev server again and make a call to get health endpoint. As you can see, the result is the same. The error stack references the TypeScript file instead of the JavaScript one. If we would like to have the benefit of source maps in production, we can add a source map flag to the build command and enable source maps flag to the start command. But if we decide that we want to have a smaller code base in production and forgo the map files, we can just remove these flags. I think this approach is more flexible than using source map option in the tsconfig.json file. Have you ever struggled with a messy, tightly coupled code that make your Node.js app hard to scale and maintain? The ports and adapters pattern, also known as hexagonal architecture, is here to change that. In this video, we'll break down how this pattern helps you decouple business logic from external dependencies, making your app more flexible, testable, and future-proof. Imagine we have an application that needs to send emails. It uses SendGrid email service in several controllers. All is great till we decide to save money and use Mailgun instead of SendGrid. Now we have to update every place in the code where we used SendGrid with a code that uses Mailgun. Not exactly efficient. And on top of that, the mailer, be that SendGrid or Mailgun, is tightly coupled to the business logic. This coupling makes it hard to maintain, test, and scale. To solve this problem, Dr. Alistair Cockburn created the ports and adapters architecture pattern, also known as hexagonal architecture. Think of application, usually drawn as a hexagon, as the central object in the system. A port serves as an entry point for external interactions, while an adapter bridges the communication between the system and outside technologies, such as databases, HTTP requests, message queues, or in our case, mailers, ensuring seamless integration. The application focuses on the problem itself, so the solution doesn't involve a specific technology, thus breaking tight coupling. There is an article by Felipe Flores that explains this in more detail. I will link it in the description below. All these ports and adapters and hexagonal architecture is a pretty cool idea, but how do we implement it? Well, when in doubt, use interfaces. To decouple our controllers from specific mailer implementation, we can use a mailer interface. Now the controllers depend on the interface and SendGrid, Mailgun, and we can even create our own console log mailer, implement the interface. The interface is the port and the mailers are the adapters. This pattern also aligns with a D in solid that stands for dependency inversion principle, meaning high-level modules should not depend on low-level modules, but rather both should depend on abstractions. In our case, controllers are high-level modules, mailers are low-level modules, and they both depend on the interface, which is essentially an abstraction. Before we jump in the code and start implementing ports and adapters pattern, let's quickly look at the sequential diagram of the implementation. Here I'm introducing create task use case. Use cases are useful, pun intended, when you need to perform several actions like create a task and send an email, or create a customer, create an order, create a payment method, and charge this payment method with the order's total. Use cases keep controllers clean. So the task controller calls execute method on the create task use case. The use case calls create task on the repository. When the task is created, the use case calls send method on the mailer to send an email. This is what we're going to implement. But before we do that, if you are learning something new, please click the like button and subscribe to our channel for more videos like this. I am in Node.js Express API project. This is a task manager app. Let's imagine that there is a requirement to notify an administrator via an email when a task is created by a user. We're going to start implementing this requirement by defining interfaces in src services mailer interface.ts file. In this file, we will define iMailer notification interface with properties 2 for the receiver email address, subject of the email, text of the email, and optionally HTML in case we would like to send an email in HTML format. The next interface is iMailer interface that has a method send with an argument mail notification of type iMail notification and return type of promise void. So all the mailers that are going to be created need to implement this method send. Now let's create a mailer. We are not going to create SendGrid or Mailgun mailers. Instead, we will create a Mailtrap mailer. I have been using it since my Laravel days. It is great for testing emails. It also has an option for sending real emails as well. When you create a test mailbox, it shows you how you can integrate it with different technologies such as CURL, PHP, Node.js, etc. Let's go to PHP, select Laravel 9+, and copy environment variables that are provided. We're going to put them in .env file. And don't forget to replace mail password variable with a value of a real Mailtrap password. We will also add admin email environment variable that contains admin's email. This will be our to email. Next, let's go back to Mailtrap and select Node.js. Mailtrap suggests to use Node Mailer library. Let's go ahead and do just that. Let's install Node Mailer library with a npm install Node Mailer and the types for Node Mailer as dev dependency with npm install it types Node Mailer --save dev. Next, we create Mailtrap mailer.ts file in src services mailers Mailtrap mailer folder. In Mailtrap mailer.ts file, we will put the following code. We're going to import Node Mailer, iMailer, and iMail notification interfaces that we just created, config, and SMTP transport type. Mailtrap mailer class is going to implement iMailer interface and create Node Mailer transporter in the constructor. The async method send will take mail notification object as a parameter and use the transporter to send an email using sendMail method, setting the recipient, subject, and message content from the provided mail notification object. Now let's define configuration mail values that we used to define transporter options in config.ts file. We will add a mail object that will pull the mail values from the .env file. We will also add admin email config option that we will use later. Now let's create index.ts file in src services mailer Mailtrap mailer folder. In this index.ts file, we will just import Mailtrap mailer class, instantiate it, and export the mailer instance. Next, let's create another index.ts file in src services mailer folder and import mailer as Mailtrap mailer from Mailtrap mailer and iMailer interface. We will assign this Mailtrap mailer to a mailer constant and export that constant. For now, it seems to be pretty redundant to have this index.ts file, but it will come pretty handy if you have different implementations of the mailer. Finally, let's create task usecase.ts file in src use cases folder. In this file, we will import a request from Express, the iMailer interface, repository, config, and logger. We will create task use case that will accept Express request and mailer in its constructor. There is a fancy phrase for passing dependencies in the constructor or methods. It's called dependency injection. In our case, we are passing a mailer as a dependency in a constructor, but you can also pass it in the class method. It doesn't really matter. The main thing to note is that we are typing the mailer not as Mailtrap mailer, but as iMailer interface. So our create task use case doesn't depend on a concrete implementation of the mailer, but rather on the abstract interface. By depending on the abstract interface, we are inverting the dependency, thus having dependency inversion or D in solid. I hope it is clear now how dependency inversion principle is used in ports and adapters architecture. Let's move on. Next, we are going to define execute method. First, we're going to create a task. After the task is created, we can use the mailer and its send method to send an email to an administrator to review the task. Sending an email in the code is a bit slow in general, therefore we're not going to wait till the promise resolves. We will just use catch to catch errors, if any, and log them out. Also, we're not checking if a task is created with an if statement because in our case, if it fails to be created, an error will be thrown and handled in the error handler. However, as a rule of thumb, it is a good idea to use an if statement to check if the entity exists before using it in the mailer. But if you're doing TypeScript correctly, it will warn you anyway. Let's go ahead and write up the create task use case in the tasks controller create task function. We will import mailer and create task use case in the tasks controller. In create task function, we will instantiate create task use case with arguments rec and mailer and call execute method. We're all set. Let's start up the dev server with npm run dev command. Go to API test.http file and make a call to create task endpoint. We will create task with a name refactor code and send the request. The task was created successfully. Now let's go to Mailtrap and look at the test mailbox where we can see an email with the subject new task and the message that the task refactor code was created. Pretty cool, huh? Now let's make things even cooler. Let's create another mailer. This time it will be our own custom implementation of console log mailer. Let's create a file console log mailer.ts in src services mailer console log mailer folder. We're going to import imailer and imailer notification interfaces. Then we're going to create console log mailer class that implements imailer interface. This class has a single method send that logs out the mail notification text. Now let's create index.ts file in src services mailer console log mailer folder where we import the console log mailer, instantiate it, and export it out. Let's jump into .env file and define a variable console log emails to be true and update the configuration in config.ts file to use this variable. Now that index.ts file in src services mailer folder that we created earlier is not redundant anymore. In this file, let's import console log mailer from console log mailer and config from config. We can now add logic to check if the console log emails variable is on, and then use console log mailer if it is. Using this logic can be pretty useful during development or testing, so you don't hit your mailer's API all the time. Also, a pattern where you use different implementation of a service or a class depending on configuration variable is known a strategy pattern. Okay, let's go ahead and check if our console mailer strategy works. Let's spin up the dev server with npm run dev, and in API test.http file, let's create another task called implement strategy pattern. The task was created successfully. If we open the terminal, we can see the message implement strategy pattern task was created and ready for the review. If we switch to Mailtrap's test mailbox, we don't see that email there, so our code uses only console log mailer. Have you ever built an API only to find your data layer turning into a tangled mess? Entities and DTOs, or data transfer objects, can help you structure your app the right way. In this video, we'll break down how to separate business logic from data representation, making your APIs more maintainable, scalable, and efficient. Often, APIs not only do CRUD, create, read, update, or delete operations, but also perform logic on its data. We are in Task Manager Node.js Express API project, and imagine we have a requirement to set task as completed only if it was not completed before. To do that, we can represent a task as an entity. Entities collocate core data models and related business logic. Besides the task properties, the task entity can also include mark as complete functionality or method. This method will check if the task is already completed. If so, we'll throw an error, otherwise it will complete the task. After a completed task is saved in the database, we will need to return it to the user. That's where DTOs come into play. In an API, DTOs help to control what data is exposed to the client and simplifies the structure of the complex objects. A classic example is when API returns a user object and it needs to exclude the password and other sensitive data. In our case, we want to exclude created at date. Besides excluding certain data, we also may want to add some calculated data, such as priority level. Alright, let's see how to use entities and DTOs in the code. As usual, the link to the GitHub repository is in the description below. Let's create task.ts file in src data entities folder. The class task is going to implement iTask interface from the repository. We pretty much are going to load data from the repository into the task entity. Therefore, we will create the task fields and initialize them in the constructor. Next, let's create a method mark as completed. It will check if completed on already has value. If not, it will assign it to today's date. If completed on already has value, meaning it has been completed, the method will throw an error. We will add more code to this class a little bit later, but for now we are done. Let's create a route to mark the task as complete. In src routes we want tasks index.ts file, let's define a patch method for the route id complete, and a handler function mark task as completed. This handler function doesn't exist yet. Let's import it and define it in the controller. In the controller, let's define async function mark task as completed. In this function, we will call getTask method on the repository to get task data. Now we need to load this data into the task entity. We can just use a constructor we created and map the values that we received from the repository. However, there is an easier way to do it. We can use a package called class transformer. Let's go to its npm page. Class transformer allows you to transform plain object to some instance and vice versa. To install it in Node.js project, we will need to install the library itself and also reflect metadata library. So let's do just that with npm install class transformer and reflect metadata. Also, let's import reflect metadata in src index.ts file as the documentation suggests. Now we can create a task entity by calling plain to instance method and passing to it task and task data that we got from the repository. Let's call mark as completed method on the task instance, persist task in the database by calling update task method on the repository and return the task back in the response. Finally, let's import plain to instance method from class transformer and task from the task entity. And it looks like we got a bit ahead of ourselves and returned the task as DTO. Let's remove this method for now. And we're all set. Let's spin up the dev server with npm run dev. We'll go to API test.http file and create an HTTP call to mark task as complete. After we make the call, we get a task back that has value in the completed on field. If we make a call again, we can see that we got an error because the task has been already completed. So the code works. Next, let's work on the task DTO or data transfer object, because what we are currently returning to the user may not be exactly what we want to return. Let's go ahead and create dto.d.ts file in src folder. In this file, let's create task DTO type. It will have properties ID, user ID, project ID, name, description, due date, completed on, and priority level. As you noticed, we decided not to expose to the user created at field, and we also added priority level field that can be high, low, or null. Let's make some updates to the task entity so we can return the task the way the DTO tells us. In task entity, let's create a method setPriorityLevel. This method is basically checking if due date exists on a task. If it does and it is within 1 day from today, then the task priority level is high, otherwise it's low. Now let's define priority level getter with a getPriorityLevel that will return setPriorityLevel method call. Finally, let's define sDTO method on the task entity. In this method, we need to map task entity fields into the plain task DTO object. However, there is a way to automate it with a class transformer package using instance to plain method. Unfortunately, this method returns a record string any type, so the best thing we can do is to cast it as a task DTO type. In order to tell class transformer to exclude created at field and at priority level field, we will use decorators. Let's go to tsconfig.json file and turn on decorators, setting experimental decorators property to true. Next, we will add exclude decorator to created at property and pass it to plain only true. This means we want to exclude created at only when we are converting our entity to a plain DTO. When we create an entity from an object provided by the repository, it will keep created at property. We will also add expose decorator to the priority level getter and pass it name priority level. This exact property appears on the DTO. There are other useful decorators you can use when working with a class transformer library. For example, @date will convert a property to the date type. To learn more how to use class transformer, check out its documentation. Finally, let's import the decorators and instance to plain method from class transformer at the top of the task entity file. Now, let's jump back into the task controller and return task as DTO in the response of mark task as completed function. We will need to update other functions in the tasks controller so they return task DTO as well. Let's update getTask and list tasks together, and you can do the rest on your own. After the methods are updated, let's make sure the dev server is running and head to API test.http file to test our work. Let's send request to getTasks endpoint. As you can see, the tasks are returned in the DTO format. If we get a task by ID, we can see the same thing. The task doesn't have created at property and has an additional property priority level that we calculated on the fly. So our refactoring worked. And this is how you can introduce entities to more effectively execute business logic and DTOs to control what data is exposed to the client. Ever deployed an API only to have it break unexpectedly? Unit testing can save you from that nightmare. In this video, we'll dive into testing Express API in Node.js, covering best practices and ensuring your endpoints work as expected before they hit production. So what is unit testing? Unit testing is a software testing method where individual units or components of a program are tested in isolation to verify they work correctly. These tests are typically automated and focus on a small, specific pieces of code, such as functions or methods, ensuring they return the expected output for given inputs. Unit testing helps catch bugs early, improves code reliability, and makes refactoring safer. In this video, we're going to cover rather simple examples where an SUT or system under test doesn't really have dependencies or dependencies are easy to simulate. For more advanced unit testing techniques where you have to use mocks, please check out our next video. I am in Node.js Express Task Manager API project. Let's write some unit tests for it. Earlier in this project, we installed Jest. In the tests folder, we initially wrote a simple test to prove everything was working. Let's create more meaningful tests. Usually, the low-hanging fruit and easy tests to write will be your utils functions. Utils functions in most cases are pure functions, meaning they always return the same output for the same input, meaning they are deterministic and have no side effects. They don't modify external states such as variables, database, or UI. For example, function add in utils.ts file is a pure function. Another pure function is getErrorMessage. This function returns error message from different types of inputs like an error, an object, a string, etc. Let's write some unit tests for it. In src test folder, let's create utils.test.ts file. In this file, let's import getErrorMessage from @utils. Let's call describe function and pass it the description of our test, in our case, getErrorMessage, and a callback function. In this callback function, let's call another function, test, and pass it a name of the test. Should return message from an error instance. Let's define an error with a message something went wrong. Now we can do an assertion using expect. We will expect the returned message to be something went wrong. If you are new to Jest, I suggest going to the Jest documentation page where you can find a reference for expect and matchers. These will be your bread and butter when writing tests, so be sure to check them out. With that foundation in place, let's move on and create another test. Should return message from an object with a message property. In this case, we'll define an error as an object with a message property, and just like before, we expect the getErrorMessage function to return the correct message string. There are a lot more test cases to write for this function, but you can cheat and just ask ChatGPT or whatever IDE AI plugin you have, like a Copilot, to write tests for you. AI does a pretty good job at writing tests. Meanwhile, let's run npm run test to make sure our tests work. After running npm run test, we can see that our tests are passing. Another function that we have in the utils.ts file is getPagination parameters. This function is a bit more complex because it takes an express request as a dependency, so we'll have to do some work to simulate it. In the utils.cs file, let's import request from express config from add_config and get pagination parameters function from add_utils. Let's describe our set of tests as get pagination parameters and pass a callback function. In this function, let's write a first test should return default values when page and per page are missing. We're going to create a request object with empty query and cast it as express request and make an assertion that we expect get pagination parameters function to output default pagination parameters when the request is passed to it. The second test we will write is called should parse valid page and per page values. We will create a rec object with the query parameters page equals 2 and per page equals 20. Sometimes TypeScript will complain if you cast an object to express a request directly. So first you may have to cast it to unknown and then as request. We will assert that when we call get pagination parameters with the request that we just created, we will get a valid pagination parameters object. Obviously, there are more tests you can write for get pagination parameters function. I will leave it up to you to practice. We will just run npm run test to make sure the tests are passing. The next low-hanging fruit in your code can be a class that doesn't have dependencies. For example, we have task entity class. Well, this class depends on class transformer library, but this is actually what we want to test. We want to see if this class correctly marks a task as completed, sets priority level, and displays priority level as property on the DTO or data transfer object we are returning as an API response. Let's go ahead and create task.test.ts file in src tests folder. We're going to import task from add data entities task and use describe function to describe the task entity set of tests. Before calling the test function, we will first do a quick setup. We will define a mock date that is an arbitrary date of January 1st, 2025. Then we will create a task entity. We will use a new task instance in each test. Therefore, we will use before each function to create a new task with the default properties. The first test simply checks that a task instance is initialized correctly by running simple assertions on the task properties. In the next test, we will check if the task can be marked as completed. First, we make sure completed on is null. Next, we call mark as completed method on the task. Finally, we check that completed on is instance of date. To be instance of date is a better assertion than testing for a specific date because there will be some time difference from when the task is marked as completed and when we actually check completed on date. In the next test, we check if the error is thrown when marking an already completed task as completed. Since before each creates a fresh instance of a task, for each test, we can just mark task as completed. Then, in the assertion, we mark the task as completed again and expect that an error is thrown. In toThrow method, you can check for a specific error or error message, but later you may change error message or error type, so it is safer to just check if an error is thrown in general. The next test tests the logic of setting a priority level. The requirement is that if due date is within 1 day from today, the priority level should be set to high. If it is more than 1 day, let's say 7 days, the priority level is set to low. And if the due date is not defined, in other words, it is null, the priority level should be null as well. Finally, we can test that the DTO or data transfer object is created correctly. In our case, we need to be sure that created at property is excluded and priority level property is added. We create test DTO by calling asDTO method on the task instance and then check that the task DTO doesn't have property created at, but it has property priority level. We are done. Let's run npm run test and the tests are passing. Before we call it quits for this video, let me also show you how to run test coverage report with Jest. You can do it quite easily by calling npm run test -- coverage. Don't skip the first 2 dashes. You need them to pass a flag, in our case coverage, when using npm command. Jest ran the tests and also provided a coverage report. As you can see, we covered 100% of task.cs file and about 50% of utils.cs. Test coverage shouldn't be your only metric to determine good tests. From my experience, certain companies may require you to have about 80% of test coverage. As a rule of thumb, though, test the code that contains logic. If it doesn't, you may not need to test it. Think your Express API is well tested? Think again. In this video, we'll dive deep into advanced unit testing techniques for Node.js application, covering best practices, mocking dependencies, and ensuring your API is bulletproof. When building an application, our code can be represented as a dependency chain of modules. Module A depends on Module B and C. Module B depends on a library, let's say Axios. Module C depends on Module D, and Module D can also depend on a library such as Sequelize. To explore this chain, we can look at two modules in isolation. Let's say one of them is a client and the other one is a server. The client module requests some kind of data and the server module provides it. Testing the server is easy, at least in this isolated case, because it doesn't have any dependencies. But testing client is a bit harder because besides simple state tests that don't require any dependencies on the client, except for maybe standard libraries, we also need to write collaboration tests since the client depends on the server. By the way, if you would like to learn how to write state unit tests, please check out earlier video on mastering unit testing. So, in order to write the collaboration test, we need to answer two questions. On one hand, does the client call the server's methods correctly, meaning the client calls the correct method with correct arguments? On the other hand, does the client handle responses returned by the server correctly? For example, if a client is asking for a collection of tasks and the server responds with only one task in that collection, does the client return back this one task or does it redirect to that specific tasks page? Or what happens if the server throws an error? Does the client handle it correctly and doesn't break? To answer these questions, we don't necessarily need the server. The server can depend on ORM and have a connection to the database. This will complicate the tests, making them slower and database dependent. So instead of the server, we can use mocks and stubs. To answer the first question, we can create a mock. A mock is essentially a server's test double that mimics the behavior or methods of the server. For example, we can create a server's mock that will have create task method. Now we can test if the client calls that method with correct arguments. To answer the second question, we will need a stub. A stub is a hard coding the mocks method to return a specific answer that is convenient to the current test. For example, the client's create task method can return a newly created task. Now we can test if the client correctly handles this newly created task. As an aside, besides mocks and stubs, there is also a spy. A spy in testing is a wrapper around an object that gives information on how this object is interacted with. Unlike mock, spy doesn't replace an object. If you have a repository, a spy won't replace its methods. This repository will still interact with the ORM and database. The spy will give you the information about the interaction, for instance, which methods are called and with what arguments. I tend to use spies very infrequently. For the most part, I use mocks and stubs. Okay, so after the collaboration tests are created using mocks and stubs, there is actually one more thing that needs to be taken care of. When we use the server's create task method, there is also an implied contract. Create task method should return a new task. We stop this return for the client's test, but ideally we also need to be sure that when we test the server's create task method, it actually returns a new task. These contract tests can be hard to write because you will need an actual clean database to make sure the task is created and returned by the server. If you are dealing with a third-party API that you don't have control of, these contract tests may be even impossible to create. In reality, with the third-party integrations, most of the time you will have to assume the contract will be respected. I hope now you can see the pattern here. If the server depends on another module, now the server becomes a client and that other module becomes a server, and you write the state and collaboration test for the new client previously known as a server. And so on and so forth till you reach either a module that doesn't have any dependencies or depends on a third-party library like Sequelize that doesn't need to be tested since this library was already tested by its creators and maintainers. Okay, let's see how it looks in practice. But before we do that, if you are learning something new, please hit the like button and subscribe to our channel for more videos like this. I am in Node.js Express project. This is a task manager API that we have been building. In src routes v1 tasks controller.cs file, we have a function create task. This function instantiates create task use case with request and mailer and calls execute method on it. The result is then returned back to the user with the status 201 in JSON format. Let's see how we can test this function. In src test folder, create test controller.test.ts file. In this file, we will import request and response from Express, mailer from services mailer. We will also import create task use case from use cases, and create task function, the actual function we want to test, from the controller. Since the create task function depends on create task use case, we need to mock it. We will mock the mailer as well because we pass it to create task use case when instantiating it. Let's describe create task function. In the callback function, let's define rec and res as partial types of request and response types respectively. Execute mock is a mock for the execute method on create task use case. JSON mock and status mock are mocks for the methods status and JSON on the response. This way, we will check if the client is handling the server's response correctly. In our case, if we're setting the correct status and sending the correct JSON back to the user. After assigning the types, let's create before each function and define rec, res, execute mock, JSON mock, and status mock. Rec will have the body and the auth properties. The body will contain the payload for the task to be created. JSON mock is just a mock responses JSON method. Status mock is a mock of a status method that will have the JSON mock chain to it. Execute mock is a mock method that will be called on create task use case. Besides testing that this method is called correctly, we will also need to test if the response from that method is handled correctly. As we mentioned before, we will need execute mock to return a stub. Our stub is a task object with an ID of 1 and the name new task. Since execute method belongs to create task use case object, we will need to mock implementation of the execute method by assigning execute mock to the execute property. Finally, we are ready to write a test. As you may have noticed, you will need to be pretty good at mocking, so be sure to check JS documentation to learn how to create mocks. And as usual, feel free to ask ChatGPT for help. It does pretty good job at mocking. Let's create test function should create a task and return 200 with the task data. Inside the callback function, we will call create task function of the controller with rec and res arguments. Now we will use several assertions. We will expect that create task use case was called with a rec and mailer object. Essentially, we're testing if create task use case was instantiated with the correct arguments. Next, we test if execute mock, aka execute method, was called on create task use case instance. These two assertions make sure we call the methods correctly. Now we need to make sure we handle the response correctly. We will do that by expecting that status mock was called with a 201 created status, and the JSON object has a task property that is assigned to an object with a task ID and a task name. Let's run npm run test to make sure the test we wrote is passing. And it does. Now we need to test the dependency of the create task function, create task use case, and in particular its execute method. Let's take a look at create task use case class. The execute method uses the repository to create a task and the mailer to notify an admin that the task is created. So, to test this method, we will have to mock the repository and its create task method and the mailer and its send method. We will create a stub for the task created by the repository since it is used by the mailer. We will also make send method of the mailer to throw an error to check if it is handled correctly. Let's create task use case.test.cs file in src test folder. We're going to import create task use case from use cases, request from Express, iMailer interface, repository, config, and logger. Next, we're going to mock repository's create task method with a jest mock. We will also mock the error method of the logger to check if it is called if the error is encountered when attempting to send a notification email. Now we can call describe function to describe create task use case. As before, we will mock rec and mailer objects in before each function since we will need them to instantiate create task use case. Let's create a test called should create a task and send an email. In the async callback function, we will first create a stub for task data and make sure repository's create task method returns it. Next, we will instantiate create task use case and call its execute method. Finally, we will assert that create task method has been called with a request body and an authenticated user ID. The mailer is called with an appropriate object, and the result equals to the created task data. In the next test, we will check if an error is logged when an email notification fails. Again, we will define task data and mark it as a response of createTask method. We will also mark a rejection value that mailer's send function returns as an error. Sometimes TypeScript gets in the way of tests, so not to get in the weeds of figuring out what it doesn't like about our test code, we can simply have comments at test expect error above the code lines that cause us problems. After instantiating the createTask use case and calling execute function, we will expect the logger's error method to have been called with a mail error. Let's check if the tests we wrote are passing. This time we will run npm run test -- watch to start Jest in watch mode. This way Jest will be watching for changed files. You should be running it this way when developing. Finally, let's write a test for the mailer. Let's open mailtrapmailer.ts file in services mailer mailtrapmailer folder. Mailtrapmailer class uses node mailer library that will need to be mocked. The transporter is initialized in the constructor function. The send method uses the sendMail method on the transporter to send an email created for an object passed to sendMail. Let's create mailtrapmailer.test.ts file in the src tests folder. We will import node mailer, config, mailtrapmailer itself, and iMail notification interface. We will define sendMail mock to return email sent successfully mock. Also, we will mock node mailer's create transport method and assign sendMail mock to sendMail. Let's create describe function to describe mailtrapmailer tests. We will create a new mailtrapmailer before each test, and after each test we will clear all the mocks. Now let's create the test itself. We are testing that mailtrapmailer should send an email with the correct parameters. First, we define mail notification object. Next, we call send method on the mailer with a mailer notification object. Finally, we will do a few assertions. We will assert that createTransport was called with the correct configuration parameters, that the sendMail method, or actually its mock, was called only once, and that it was called with the correct object. After saving the file, JustWatcher detected the changes and reran the new test. Everything is passing. And there you have it. By creating state and collaboration tests as well as contract tests where possible and moving up the dependency chain, you can write a solid set of unit tests for your project. Although unit tests will be the bulk of your project's tests, sometimes you will need integration tests to make sure the components, such as middlewares, work well with the other modules. If you are building APIs with Node.js, writing reliable and maintainable tests is a must. We'll be using Jest, the fast, flexible testing framework trusted by top developers, and Supertest, a powerful tool that makes HTTP request testing a breeze. Before we begin, here's a quick outline of what we will do. First, we'll start by installing Supertest along with the TypeScript types, so we have everything set up to start writing integration tests. Next, we will write a simple test to get familiar with the workflow. We will test the health endpoint using Supertest to make sure everything is wired up correctly. Then we'll move on to a more realistic example. We'll test the createTask endpoint by mocking the underlying use case and checking that the response behaves as expected. Along the way, we will deal with authentication middleware. I will show you how to bypass it during testing so it doesn't interfere with our integration tests. After that, we will simulate an error in the createTask flow to test our error handling middleware and make sure it returns the right status code and message when things go wrong. We'll also cover request validation. I'll show you how to write a test that checks what happens when required fields like the task name are missing from the payload. And finally, we'll run test coverage report to see how our integration tests contribute to overall coverage. Even just a few tests can make a big difference. I am in Node.js Express API project. Earlier we talked about how to write unit tests for it. Although your unit tests will be the bulk of your testing, you will also need integration tests. Integration tests are helpful in various situations, and especially in testing middleware, because middleware work as an interceptor for HTTP requests, and this interaction can be hard to test using unit tests. So, to do integration tests, you will basically need to automate making requests into your API and make assertions very much like we did with unit tests. A great library for that is Supertest. Let's install it with npm install Supertest and a type Supertest with a savedev flag. In order for Supertest to make a request, we need to give it an Express app. If we look at server.ts file, we can see that create server function returns an Express app. Also, this file has a simple health route. Let's test this route to get our feet wet with a Supertest. In src tests folder, let's create integration tests.test.cs file. We're going to import Supertest and create server function from server.ts file. Let's describe our tests as health endpoint tests. Then we call test function and pass it health endpoint returns OK to 100. In async callback function, we will call Supertest with a wait and pass it Express app by calling create server function. We will make a request to health endpoint with a method get. We will expect 200 response status and OK property of the response body to be true. This is as simple as it gets when you use Supertest. Let's start just in watch mode with npm run test --watch. The test is passing. Let's write more complex tests. In routes v1 tasks controller, we have a function create task. It instantiates create task use case and calls execute method on it. The response is returned to a user with a status 201 and JSON body with a created task assigned to a property task. In the previous video, we wrote unit test for this function. Let's write the same test using Supertest. In integration test.test.cs file, let's import create task use case. We will also mock it because we are not interested in going all the way through and creating an actual task. This will require us hitting the database. When running automated tests, most of the time you won't have the database available. The automated tests should be quick. Let's describe create task integration tests. First, we will create execute mock. This is the mock for execute method on create task use case class. By default, we will resolve the returned value to null. Before each test, we will assign execute mock to execute property on the mock's implementation of create task use case. After each test, we will clear the mocks. The test itself will be it creates a new task. In the async callback, we will update execute mock to return a new task object with an ID of 1 and name new task. We will then call Supertest and pass it an Express app, the same way we did earlier. We will make a post request to v1 tasks endpoint with a payload object containing name property and value new task. We will expect to receive 201 created status. We will add a couple more assertions to expect the response body to have property task. This is basically what we're after. We need to make sure the response is returned to the user in the correct format. We will also check that the task name is new task, making sure create task function doesn't transform the output of the execute method of create task use case. After we save the file, it looks like the test is failing with a 401 unauthorized error. This is because we have authenticate user middleware that is applied to the route. In order to make this test work, we need to turn off the middleware. Let's use JustMock with a callback function that sets isModule to true and assigns default export to return a middleware function that passes through the request. Now everything works and the test is passing. Great. The next thing that we can do is to test if we have a correct response when things go sideways when creating a task. Create task function of the task controller doesn't handle errors. Errors are handled in the error handler middleware. Therefore, it may be hard to test error handling with unit tests. That's where we can make our life easier and use integration tests with a Supertest. Let's take a look at error handler middleware. It handles different types of errors such as validation, custom, and unauthorized. At the end, the middleware handles an error that doesn't belong to any of the types above. It sends a response with a status 500 and an error object with an error message. Let's write a test for it. In integration test.test.cs file, let's create a test. It returns an error when trying to create a task. We will make execute mock to mock rejected value of an error with the message error creating task. This is essentially the same as throwing an error from the execute method of create task use case. We will make a post request to v1 tasks with a new task payload and expect the response to have 500 status. We will also write an assertion that response body contains property error. After we save the file, we can see that the tests are passing. The next use case where Supertest is helpful is for testing request validation. In this project, we use validate request middleware that in turn uses Joy object schema. The schemas are defined in src data request schemas.cs file. Create task schema uses the task object that defines Joy validations. According to these validations, the task name is required. If the task name is missing or any validation fails, for that matter, the validate request will throw an error that will handle in error handler middleware as validation error. The error handler will respond with a 422 HTTP status, an error object containing message, error code, error valid, and mapped error messages. Let's write a test for that. The test will be it validates task's payload by requiring a task name. We will use Supertest to make a post request to v1 task's endpoint with a payload containing only the description of the task. We will expect to get 422 response status. We will assert that the response body contains an error object with error code error valid. Let's save the file. The jest watcher reruns the tests and we can see that they are passing. Finally, we can run coverage report with npm run test -- coverage. Although we only wrote a couple of integration tests, our test coverage increased significantly. This is because by definition, integration tests touch several modules. I'm usually a bit careful with integration tests because they can provide a false sense of security. Bulk of my tests are unit tests, and I usually use Supertest to test middleware and use cases where I have redirection in my code. I think integration tests are very suited for that. After you test your project, it is time to deploy it. If you are building a Node.js application and thinking about deployment, you're in the right place. In this video, we will walk through how to Dockerize your Node.js application and test the image locally using Docker Compose. Whether you are deploying your app to containers, running app on a virtual instance, or even hosting small services on Lambda, one tool stays constant: Docker. It's a powerful way to build consistent portable environments across all stages of development and deployment. I usually deploy my applications in 3 ways. The first one is using ECS containers fronted with a load balancer for scalability. This is an enterprise-level deployment meant for high traffic. Together with a database, it can cost a little bit of money, so I normally do it for projects at work. The second way is deploying an application using Docker Compose on a virtual server, for example EC2 instance. This may not seem to be cheap at first, but if you manage to deploy 4 or 5 applications on the same server, front them with an Nginx reverse proxy, and use free Let's Encrypt certificates, this becomes a pretty cheap option for your pet projects. Finally, I sometimes use Lambda with a Lambda function URL. Usually I do it for small internal services that don't get much traffic or an internal API documentation such as Swagger. The common denominator in all of these deployments is Docker. Let's take a look at how we can Dockerize the Node.js Express Task Manager API that we have been building. So, what is Docker? Docker is an open source platform that enables developers to automate the deployment, scaling, and management of application using containerization. A container is a lightweight, standalone, and executable package that includes everything needed to run a piece of software, code, runtime, libraries, and dependencies, so it works reliably across different computing environments. Unlike traditional virtual machines, containers share the host system's operating system, making them more efficient and faster to start. With Docker, you can ensure consistent environments. Docker also integrates seamlessly with modern CI/CD pipelines, cloud platforms, and orchestration tools like Kubernetes. This makes it ideal for building microservices, architectures, testing distributed systems, and simplifying the software delivery process. With a little bit of a background on Docker, let's start Dockerizing our application. The first thing I do is I create a .dockerignore file. You put in this file all the stuff from your project that are not needed for the deployment. Let's create that dockerignore file in the root of our project. In this file, we'll put the following content: node modules, dist, .env, .example, .vscode, .github, and .husky. We kind of need node modules and dist folders to run our application. However, we will be installing dependencies and building the application in a Docker container, so we won't need the ones that we have in the project. The next file that we create in the root of our project is Docker file with a capital D. If you are using VS Code, you may want to install Docker plugin for VS Code. We will be building our image based on Node.22 Alpine image. It is a small image that contains only essential stuff. At the time of recording, Node.22 is a long-term support version. Depending on when you are watching this, you may want to use a different Node version. I also like to use multi-stage builds for my Docker images, therefore the first stage will be a builder stage. Multi-stage builds allow you to separate different parts of the build process into distinct stages. For example, one stage builder can handle compiling or building your app, and another installer or runner can create a slim final image by copying only the necessary artifacts, reducing image size, and improving security. APK is a package manager for Node Alpine similar to NPM. We will use it to install libc6 compact library. This is a shared library that may be needed, so it's better to install it. Next, we will set working directory as app and copy all the files into it. That's when Docker will ignore files that we specified in Docker ignore. We will run npm install and npm run build. Now let's create installer stage. We will use Node.22 Alpine as installer. Besides installing libc6 compact, we will also install OpenSSL. This library will be needed for Prisma. Again, we set working directory as app. We will copy only specific files from the builder stage, dist and Prisma folders, and package.json and package lock.json. We will run npm CI. CI stands for clean install. It uses package lock.json exactly as it is to install the dependencies and also removes node modules folder if it is present before running the install. We will also use omit equals dev flag to not install dev dependencies. We already used dev dependencies to build our project in the previous stage and don't need them anymore. If you don't separate your dev and prod dependencies when working on a project, you may not want to use this flag. Finally, we will run Prisma generate to generate Prisma client. Now we will create the last stage, the runner stage. As in the previous stages, we will install dependencies with APK with set app as the working directory. Not running production as a root also applies to images. We will set a group and a user called Express.js. This user will be running the app. Then we will copy the app folder from the installer stage and do cmd npm run docker start. It is important to put the parts of the npm run docker start as an array instead of the actual command. Our Docker file is complete. Let's go ahead and create the docker start script in package.json. But before we do that, if you're learning something new, please hit the like button and subscribe to our channel for more videos like this. Docker start script needs to do two things: run migrations and start the application. We have scripts for both of these tasks, therefore we can combine them together with npm run migrate and npm run start. The final step that I do before deploying my application is test it locally. In our case, all I care is that the app actually connects to the database, runs migrations, and starts up. So we will need to deploy the API and the database locally. The easiest way to do this is with a Docker Compose. Also, to be able to run Docker on your local machine, you will need to install it. I use Docker Desktop, so I suggest installing that if you don't already have it installed. Let's create Docker Compose YAML file in the root of our project. We will define version 3.8. There will be two services. One of them is app. It will be built from the current folder using Docker file named Dockerfile. Minimally, to test the app, we will need only database URL and node.env environment variable. Docker Compose is a great way to test an API in production-like environment. If you want to test other features such as authentication, feel free to add more environment variables. Also, please note that in the context of Docker Compose, the database server is not localhost anymore, but DB. This is how our database service will be called. We will define it in a little bit. We will also specify that app service depends on a database service and map port 3000 of Docker container to the port 3000 on local machine. Next, let's define database service. We will call it DB. We will use MySQL 8.0 image. In the environment, we will put password, secret, and MySQL database task manager. We will also map the port 3306 in the database Docker container to 33061 on the local machine. 3306 is the port that MySQL runs on in the container. On the local machine, I already have port 3306 taken by MySQL development database, so I'm using the port 33061. Database will need to store data. Let's map DB data volume to varlib MySQL. Finally, we will define DB data volume under the volume section. And we're all set. Let's start up Docker Compose with a command docker compose up-d. -d means Docker Compose will be running in a detached mode. It may take some time for Docker Compose to start up, because first it will download the image for MySQL 8.0 and set up the database, then it will build an app, and finally it will deploy the Docker containers. After the Docker is deployed, we can go to Docker Desktop. We can see that only one of the containers is running. Let's expand Node and Express.js app and click on View Details for App Container. We can see that there is an error. P1001 can reach database server at DB 3306. This happened because Docker Compose had to set up the database task manager, so our app tried to connect to it before it was ready. Setting up the database is a one-time process. Let's stop Docker Compose with the command docker compose down, and then start it again with docker compose up-d. When we go and view details for the container again, we can see that the app connected to the database and migrations ran successfully. However, we have permission issue creating logs directory. We're trying to create logs directory for Winston file logger. Creating logs inside the Docker container is not a good idea. They are hard to access and will bloat your container. Normally, you would send your logs to a log service or use a cloud logging service such as CloudWatch. By the way, if you would like to learn more about CloudWatch on AWS, please check out this video. Let's go ahead and bring down Docker Compose. We will go into src logger.cs file and comment out the file transport logger code. Since we made updates to our code, we will need to rebuild the app. We can do it with a command docker compose up-d with a build flag. Now, if we go to Docker Desktop, we can see both containers are running. Since we bounded our app container to port 3000 on our local machine, we can now do a quick test by making a GET request to the health endpoint of our application. And we can see that the application is responding. Everything is working. Finally, if you're happy how the application works on your local machine and you don't need the images and volumes that Docker Compose created, you can run command docker compose down --rmi all --volumes. This will stop and remove containers, remove all images defined in the Docker Compose file, and remove attached volumes. And this wraps up the workflow you can use to Dockerize your application and test it locally. Now you can deploy your application the way you like it. If you would like to learn how to deploy your application to an ECS container on AWS, please watch this video next.